Hello everyone, my name is Emmanuel Jijon and welcome to this free, all-inclusive Linux course for absolute beginners. If you have heard about Linux but don't know what it's all about or where to start, you're in the right place. I'm a DevOps engineer with years of hands-on experience across different industries, from the cloud to high-scale infrastructures. I've seen firsthand how knowing Linux can completely transform your career prospect, especially in the tech world. I've also heard people say Linux is for people with a background in tech. But here's the good news. You don't need to be an IT professional or have an IT background to understand and benefit from Linux. Why? Because Linux is everywhere. It's the backbone of the internet. The software in many smart devices, such as smartphones, smart TVs, IoT devices, gaming devices, and even in cars. And it powers some of the world's biggest companies like Google, Amazon, Facebook, and even Netflix. There is this idea out there that Linux is complicated and only for people with a background in tech. But that's not true. Linux is not complicated, and learning it does not require any technical background. In this course, I'm going to take you step by step from absolute zero, no IT background, no prior tech experience, just curiosity and the willingness to learn to become a confident Linux user. Together, we will explore the fundamentals, break down the myths, and make Linux easy, accessible, and maybe even fun. And did I mention this course is 100% free with no strings attached? Why? Because I believe that knowledge is meant to be shared, and Linux is one of the most empowering tools for leveling up your skills, kickstarting a career in technology, or trying something new. Learning Linux will open up incredible opportunities for you, believe me. Whether you want to be a cybersecurity engineer, a systems engineer, a DevOps engineer, a cloud engineer, or even a software developer, learning Linux will help you get there. And this course will show you exactly how to get there. So, whether you're a student, a stay-at-home parent, a curious learner, or someone thinking about a career shift to tech, this course is for you. Please hit that subscribe button, grab a cup of coffee, and embark on this exciting journey of learning Linux. In my next video, I will explain what Linux is and why it's important for you to know it. Thank you for watching this video, and please remember to hit that subscribe button, and see you in my next video. Bye. Hello guys, and welcome back to part 1 of our free Linux course. In today's video, I will explain what Linux is. I'll also explain the meaning of open source software and also explain what an operating system is. I will also explain the benefits of Linux over other operating systems like Windows and macOS. And I will end this video by explaining the Linux distributions and the different types of Linux distributions that exist. Please note that some of the things I will explain in this video are what you will need to build a strong foundation in Linux as we move forward. If possible, grab a piece of paper and take some notes. As I'm explaining, if you have any questions, please comment below and I'll be more than happy to make a separate video to answer your questions. Without taking much of your time, let's get started. So, what is Linux? Linux is an open source operating system that powers various devices, from personal computers to servers, smartphones, and even embedded systems like smart TVs. It is an operating system known for its stability, security, and flexibility. So that's what Linux is. Linux is simply an open source operating system. In this definition of Linux, I mentioned two confusing things for someone new to Linux or IT. I mentioned open source and I mentioned operating system. So when they say something is open source, what does that mean? An open source refers to a type of software or project in which the source code, that is the actual programming code that makes the software to work, is freely available to the public. This means anyone can view, modify, distribute, and contribute to improving that software. That's my definition. So let's look at what Wikipedia has to say about open source software. So if we go to Wikipedia right here, right now I'm on Wikipedia. As you can see, Wikipedia says open source is a computer software that is released under a license in which the copyright holder grants users the right to use, study, change, and distribute the software and its source code to anyone and for any purpose. It means an open source software, it's a software which, the license right here or the copyright has been granted to anyone who want to use it. So anyone can take an open source software, anyone can, can view it, anyone can modify it, anyone can distribute it, or anyone can contribute to making it better. And that's exactly what Linux is. Linux is an open source, software. It means that the actual code of Linux can be found online. So for example, if I go to Google and I type Linux GitHub repository right here, as you can see, this repository is going to pop up. This one right here is going to pop up. So let's click on it. So if I click on that, it's going to take me to this Linux repository. So what is a repository? A repository is simply a place where you store code. But I want you to note that right now, knowing what a repository is not important, because I'm going to create a separate course that's going to teach you what repositories are and how to use them, right? The course will be titled Git and GitHub, right? That will be a separate course. So right now, knowing exactly what a repository is not that important. So let's continue. So as you can see right here, we're on the Linux repository. How do I know it's a Linux repository? If I click on this guy, you're going to see this guy, Linux Torvalds. I hope I'm pronouncing his name correctly. So this is the guy who created Linux. This is the guy who, came up with the idea of Linux and started building Linux. And when I go through his GitHub account, I can see a couple of, repositories. And right here, I can see the Linux repository. And the first thing I notice from the Linux repository is that it's public, right? It means anyone can access it, anyone can view it, anyone can download it, anyone can modify it, and anyone can use it. You can even resell it if you want to. So I'm going to click on this. And when I click on this, it takes me straight to this repository right here. So what am I looking at? I'm looking at the source code of Linux. I'm looking at the actual code that makes it possible for Linux to work. Now, if you're brand new to Linux, you're brand new to IT, all of this is going to sound confusing. But you know what? Do not get yourself over confused. Do not try to understand everything at the same time, right? Just, focus on the Linux part and don't worry about source code. Don't worry about all of these things. But what I'm looking at right now, I'm looking at the code that makes it possible for Linux to work. And the reason why I'm looking at this code here is because Linux is what? It's open source, right? Anyone can see it, anyone can view, anyone can download it. So the first thing I notice here is that there've been 1.3 million commits to this repository. Still, don't worry about what the commit is. And the last time they updated this repository was 2 days ago. Now, when you look on the right side, you find this about, right? And under this about, you have some information about this, about Linux. For example, you can go to their readme. You can view their license. You can see how many people are watching currently. There's 7,000 people that are currently watching this. And you can also see that Linux has 15,000 plus contributors. It means there are 15,000 plus people out there that are working every single day to make Linux, a better operating system than most of the operating systems out there. So that's kind of what open source means. Open source means that anyone can view, anyone can modify it, anyone can distribute it, and anyone can even contribute to improving it. I know now you're asking yourself, Emmanuel, why would someone want to make this open source? Why would someone want to make something as great as Linux open source? The whole idea of open source is to encourage collaboration, is to encourage transparency, and it's also to create an environment of shared improvement where people can come together, contribute, and build something something better. As you can see, there are 15,000 people that are working every single day to make Linux better. Now, if you try to go look at the source code of for example, Windows, you're not going to find it. Why? Because it's not open source. If you try to go look for the source code of Mac OS, you're not going to find it. Why? Because it's not, it's not open source. So that's what open source is. So whenever I say Linux is an open source operating system, I want you to know that the word open source then means that it's freely available. The source code, the actual code that makes it possible for Linux to work, is freely available, and you can download it, you can modify it, you can sell it, you can do whatever thing you want to do with it, and nobody is going to sue you. The second thing I mentioned in my definition of Linux was that Linux was also an operating system. I said Linux is an open source operating system. So the question now is, what is an operating system? An operating system is a software layer that manages computers' hardware and provides services and an interface for running applications. That's what an operating system is. Now, I know that sounds complicated to understand, but don't worry, I'm going to break it down. But before I dive in and I start breaking down what an operating system is, I also want you to know that an operating system also acts as a bridge, between the user, applications, and the computer's hardware, ensuring that, different programs and users can operate smoothly and efficiently on a machine, right? Now, let me explain this. Now, let's dive back into our computer and let me, explain a couple of things. Now, this is a computer right here, right? This is the computer right here. And this is the hardware part of a computer. So a computer is made up of three components. There's the hardware, there's the software, and there is an operating system, right? These are the things that makes up, a computer. So this is the hardware right here. And as you can see on this hardware, you have different components. For example, you have the RAM, you have the expansion card, you have the motherboard, you have the CPU cooler, you have the CPU itself, you have the PSU, you have the mouse, you have the monitor, you have the keyboard, you have speakers, and you have, the hard drives, right? All of this is what makes up, the hardware part of a computer. Hardware meaning that anything you can see, touch, or smell in the computer is part of that computer's hardware. Now, a computer does not just have hardware. A computer also has softwares, right? For example, these are softwares and applications, right? So there are softwares and there are applications, on your computer, right? So there is the software part of your computer and there's the hardware part of your computer. Now, in order for a computer to work, a computer needs both the hardware and the software. So now the question is, how does the hardware interact or communicate with the software part of your computer? That is where an operating system comes in. So an operating system is that software that's in between your computer's hardware and your computer's software. And its main responsibility is to manage the relationship between your hardware and your computer's software. So this is a diagrammatic representation of what I'm saying. So for example, this right here is a computer. This entire system right here is a computer. So the first thing you have to know about a computer is that, there are users, right? It could be, it could be me, Emmanuel, it could be John, it could be Paul, right? These are users. Now, users usually we interact with the software part of a computer. What does that mean? This is my computer right here. So if I want to do something with this computer, for example, let's say I want to play music, I will need an application to play music, right? If I want to go to the internet, I will need an application to go to the internet, right? So it means that when I'm interacting with this computer, I'm interacting with the software part of the computer. So users usually interact with the computer's software or the computer's applications, right? And both the computer's software and the computer's application, we then interact with an operating system. And that operating system, we then interact with the hardware part of the computer. And, we saw the hardware part of the computer right here, where we talked of the mouse, the keyboard, the monitor, the CPU, the RAM, the disks, and all these good things, right? And this, operating system can be any operating system in the market. It can be Linux, it can be Mac OS, or it can be, or it can be Windows. Let me explain it this way. Let's say I want to play music, right? In order for me to play music on my computer, I need a software or an application that's responsible for playing music. And is this application right here? This one right here. This one right here is the one that's responsible for playing music. So if I click on this, I, as the user, is interacting with this application right here. But what's happening in the background is that this application is interacting with my operating system. And what the application is doing is that it's telling my operating system that, hey, listen, Emmanuel wants to play music. And I need you, the operating system, to tell whatever hardware component that's responsible for playing music to, help me play this music. And in this case, guess what? The operating system is going to interact with the speakers, right? And I'll be able to listen to that music. I don't know if this makes sense. So what happens is that all the applications and softwares in your computer interact with an operating system. And in return, this operating system then interacts with the hardware part of your computer. So that's kind of how operating systems, work. So they're there to manage the relationship between, your computer's software and your computer's hardware. So they're kind of, in between. Now, I want us to look at some key features of operating system, right? So the first one that's important is that they are responsible for resource management. And I already talked about it, right? Operating systems are responsible for managing, resources within your computer. So they are responsible for managing the RAM. They are responsible for managing the CPU. They are responsible for managing, storage, and they are also responsible for managing peripheral devices like your printer, your mouse, your keyboard, and your speaker. So that's the first thing that operating systems kind of do, right? Another important thing to note is that operating systems also allocate these resources to different programs and processes, ensuring that tasks are executed efficiently. For example, if I want to play music, an operating system will be responsible of allocating or informing my speakers that I want to play music. If I want to click on something, for example, I want to click on this right here, or I want to click on something, an operating system is responsible, for telling my mouse that, hey, listen, he wants to do this, so I want you to, click on that thing. So that's kind of the first thing that operating systems do. They are there to manage, different resources. For example, as I said, the RAM, they are the one managing it. Anything that has to do with storage, they'll manage it. Anything that has to do with peripheral devices like your speaker, your keyboard, your monitor, your mouse, they are the one managing it. anything that has to do with hard drive, they are the one managing it, and they also allocate this to different programs for in order to make sure that tasks are executed efficiently. Now, the second thing that operating systems do is process management, right? An operating system is also responsible for handling running programs or processes by assigning them CPU time, managing memory, and ensuring smooth multitasking when multiple applications are running simultaneously, right? For example, let me explain this. For example, I can be playing music at the same time I can be typing an email, at the same time I can be looking at pictures. All of these are different applications. At the same time, I can be doing video editing. All of these are different applications and softwares that are running simultaneously. And these softwares need a CPU, they need memory, they need storage, they need a lot of things. And the operating system will be responsible for assigning resources to different programs. For example, the operating system will say, hey, if you're using a video editing program, you probably need more CPU, you probably need more RAM, right? So take more RAM. So the operating system is also responsible for managing processes within your computer. And it's also important that under this process management, it's also important for you to know that an operating system is also there to handle the life cycle of process within your computer. For example, if I start music, the operating system is responsible for making sure that that music starts. If I stop that music, the operating system is there to make sure that that music stops. So if I start it, if I pause it, if I resume it, if I stop it completely, the operating system is the one managing that entire process. The operating system organizes, store, retrieve, and manipulate files on storage devices, providing a file system that allows users and applications to read, write, and organize files in a structured way. That's also the job of an operating system. Now, as we progress throughout this course, we're going to come across something called file management, and we're going to see exactly how an operating system organizes files in a structural way, in a way that makes it easy for users to interact with this file. And the fourth thing that operating systems are also responsible of is security and access management, right? You can either call it security and access management, or you can call it security and access control. Is the same thing. And what happens is that operating system control access to the computer's resources by enforcing permissions and user authentications, for example, passwords, right? So if you try to log into my computer, if you try to access my computer and it asks for a password and you put in the wrong password, the operating system is, and you put in the password, the operating system is responsible for making sure that that password you inserted into that computer is allowed to access that, that computer, right? Another thing is that at times your computer is going to ask you for a username and a password, and you put a username and you put a password. The operating system is there to make sure that that username and that password are authorized to access that computer. Now, the reason why is doing this is because the operating system is trying to prevent someone who's not authorized from accessing a specific computer, and is also trying to prevent malware threats. So the operating system is kind of responsible of that as well. Another thing that's important to know about operating systems is that they also provide an interface, commonly known as a UI or a user interface, that allows interaction with the system, right? This could be a graphical user interface. Like, for example, your personal computer has a graphical user interface, right? Whether your computer is a Windows machine or whether it's a MacBook, they all have graphical user interface. Or an operating system also provides something called a command line interface, right, known as a CLI. Like for example, in Linux is command line based. It means everything you do in Linux, you have to type a specific command. So for example, on my personal laptop, if I want to open a file, I would just go click and open that file, right? But in Linux, you have to type a command in order to do that. So guys, that's what an operating system is. So next time when someone says Linux is an open source operating system, I'm sure you will know exactly what they mean by the word open source. And when they say operating system, I'm sure you have an idea of what an operating system is and how it's useful in a computer. And Linux is simply an operating system, right? Linux is an operating system just like Windows is an operating system. For example, let me give you some examples of operating system. The first one is Windows, right? And Windows is owned by Microsoft, and they are by far the most used operating system in personal computers. So if you buy a personal computer, there's a probability that it's a Windows operating system in it, and it's a commercialized type of operating system. It means Microsoft is selling it, right? And all these companies come to Microsoft, they buy it, then they go use it to build their computers, build their personal computers, and they sell it to HP, Dell, all of these guys. They're buying it from Microsoft and they're using it. The next type of operating system is Mac OS, right? Mac OS is owned by Apple and it's only used by Apple. So you find it in Apple computers right here. For example, I have a MacBook right here, and the operating system in this MacBook is Mac OS. And it's only with Apple. And you have Linux, right? Which is an open source operating system that has different distributions. Now, don't worry about what distributions are. We're going to talk about distributions in this video, right? So that's it. So you have Linux, which is an open source operating system. Then you have Android, and Android is mostly used in mobile devices, but it was built on top of Linux. So if you have an Android phone and you're using it, you're technically using Linux, right? Because the operating system in phones is Android, and Android was built on top of Linux. So if you're using an Android phone, you're technically using Linux. And the last one is iOS, which is also an operating system for mobile phones, especially used in iPhones and in tablets, right? So if you have an iPhone, the operating system in this iPhone is what? iOS. And if you have a tablet, the operating system in that tablet is iOS. So these are examples of some operating systems that exist out there. There are a ton of other operating systems, but these are just some few. You have Windows, you have Mac OS, you have Linux, you have Android, you have iOS, right? These are examples of operating. Hello guys, what's up and welcome back. My name is Emmanuel Gijon, and thank you for being here tonight. Thank you for taking the time to check out this video. So in today's video, we're going to be talking about how to set up a Linux lab environment in the cloud. So this is going to be a step-by-step guide for beginners, right? So the two important things we're going to talk about is what is a Linux lab environment in the first place? What is it, right? And the second thing we're going to talk about that's important is why is it important to even set up that Linux lab environment. So let's dive into the first one. So the first one is, what is a Linux lab environment? A Linux lab environment is a structured setup, typically using a personal computer or a cloud provider, designed to help users explore and practice Linux concepts, including system commands, configurations, troubleshooting, and administration tasks without impacting real-world systems. So what this definition is trying to explain is that a Linux lab environment is a place where you go to practice Linux. You go to practice how to run Linux commands. You go practice how to do configurations on a Linux server. You practice how to troubleshoot a a Linux server, and you also practice how to do some administrative tasks, that real world engineers are doing out there. And the beauty of setting up a Linux lab environment to practice these things is that you're not going to impact. It won't have any impact on real world systems. It means you can practice without the fear of destroying anything, right? It's a place where you go to practice, you go to learn, and you go to play. So why is it important? Why is it important for you to set up a Linux lab environment? The first one is hands-on learning, right? So you have to know that when you set up a Linux lab environment, this environment allows you to practice commands. That's the first thing. It also makes it possible for you to understand how a Linux server is being configured, or how configurations are made on a Linux server. It experience when it comes to troubleshooting a Linux server, and by doing all of this, makes it easy for you to understand Linux and different Linux concepts. So the first big advantage of setting up your Linux server is that it's going to give you some hands-on experience. The second thing is risk-free experimentation, right? When you set up your servers, your Linux lab environment, you can test new setups, you can test new softwares, you can test different configuration without having to worry that you're going to break any system or you're going to lose any data, right? So that's why it's important for you to set up, that Linux lab environment. The third reason is real-world preparation, right? A lab helps simulate real-world scenarios. So this environment will help you simulate real-world scenarios. It means engineers that are out there and they're using Linux. What are they doing? What do they do on this Linux servers on a day-to-day basis? Right? How do they connect to these Linux servers? How do they install applications? How do they use it to deploy websites or applications? Right? So this lab environment will prepare you for things like that. It will give you, a real world experience when it comes to server management, when it comes to troubleshooting, and when it comes to system administration, right? You'll be comfortable so that by the time, you're done with your whole IT course and, you go out there and you're looking for a job, and when you get your job and you start doing that job, you are extremely comfortable with, implementing what you've learned, right? So this is something that this lab will also help you to gain. So what are the different ways you can set up this lab environment? So there are two ways. The first one is you can do what I call a local setup, that you can use your laptop or your desktop. So if you have a laptop at home or you have a desktop, you can use that laptop to set up your Linux lab environment. The second way is cloud setup. So basically you go to a cloud provider, you create an account, and you use that account to set up your lab environment. So you can go to AWS, Azure, or GCP. You can create an account there, and once you create your account, then you will use that AWS account, Azure account, or GCP account to set up your lab environment. And whenever you want to practice Linux, you just log into your account and you start practicing Linux. Now let's see how to set up a Linux lab environment locally. Now for local setup, everything here is going to be theory based. I'm not going to dive into anything serious. It's just going to be theory related. So to set up a Linux lab environment locally, the first thing is that you're going to need a laptop. So let me see if I can find picture of a laptop. Cool. So you're going to need a laptop like this, or you're going to need a desktop, right? So either you get yourself a laptop, or you get yourself a desktop, right? Now we're going to assume that this right here represents your laptop right here. This represents your laptop, and this laptop can be any laptop in the market. Can be Mac OS, it can be Windows, right? It can be, any laptop with any operating system in the market. But the first thing I want you to know is that this is a physical, laptop, right? Or desktop. And your laptop and your desktop both have, an operating system, what's known as an OS, right? Your laptop and your desktop both have an operating system. And it can be any operating system. It can be Windows, or it can be be Mac OS. Please, if you don't know what operating systems are, there's a video on my channel. It's titled What is Linux? Under that video I talk about what operating systems are and how operating systems work and the different types of operating systems that exist in the market. So you're going to need a physical laptop like this, or a desktop, either a laptop or a desktop, and it's going to be a physical one. And your laptop, when you go to the market, you buy your laptop, it comes with an operating system already installed in it. If you buy, let's say, an HP computer, it comes with Windows. If you buy a Dell, it comes with Windows. But if you buy a MacBook Pro or a MacBook Air, it comes with a Mac OS operating system. But now here's the thing. Because you want to practice Linux, you cannot practice Linux on Windows because, Linux on its own is an operating system, just like Windows, just like Mac OS. So you cannot practice Linux on a Windows operating system or on a Mac OS operating system. So what you need is a Linux operating system, right? But now here's the thing. This laptop right here already has an operating system, right? Your HP laptop already has an operating system, and that operating system is Windows. And your MacBook already has an operating system, and that operating system is Mac OS. So what do? You will need to install the Linux operating system, right? You will need to install the Linux operating system so you can practice Linux on a Linux operating system. But now here's the thing. You cannot just go and you uninstall your Windows operating system and you install the Linux operating system, right? Or you cannot just go and you uninstall the Mac OS operating system, then you install the Linux operating system. That's going to be difficult to do. And moreover, your laptop is your personal computer, so you're using it to do different things. Maybe you're using it for school, you're using it for work, you're using it to do different things. So deleting your entire operating system means you're deleting everything in your laptop and installing a new operating system that you don't know how to use, right? So the way it would work is that since you cannot delete Windows or Mac OS, you will need to create a virtual machine. Remember, this is a physical machine. Your laptop or your desktop is a physical machine. So you will need to create a virtual machine, right? That will come with its own operating system, and that operating system will be Linux. So how do you create this virtual machine? So in order for you to create this virtual machine, you will need a piece of software that will make it possible for you to create this virtual machine. And that software is what they call a hypervisor, right? So you will need a hypervisor. So what is a hypervisor? A hypervisor is simply a piece of software that makes it possible for you to run multiple virtual machines on top of a physical machine, right? And there are different types of hypervisors out there. You have VirtualBox, right? You have Hyper-V, right? You have VMware, and different types of hypervisors, right? So when you install a hypervisor on your laptop or desktop, and it can be any of these hypervisors here, when you install this hypervisor on your laptop or desktop, then you will not create another type of machine, right? You will not create another type of machine. Now, in this scenario, this would be a virtual machine, and this machine will have its own operating system. And in this case, the operating system would be what? It would be Linux. And this machine would have all the components that this other machine has. For example, a RAM, a CPU, a memory, a disk, every single thing that this machine has, this other virtual machine will have it. Then you will not use this virtual machine you've created to practice Linux locally. So this is what they call, the local set, right? As you can see, local setup involves a couple of, steps. right? So first of all, you need a physical machine. And once you get that physical machine, you install a hypervisor on that physical machine. This can be VirtualBox, this can be Hyper-V, this can be VMware. Then once you have your VirtualBox installed, you now create a virtual machine with an operating system that's Linux, right? And now you have one physical machine but two operating systems. And the reason they have 2 is because, there's an operating system for that came with the original laptop, and there's now another operating system that was created when you created your virtual machine using a hypervisor. As you can see, there are a lot of steps, right, in setting up a Linux lab environment locally. A lot of steps, right? Now, I don't like this, even though this is how a lot of people do it or prefer to do it. But I don't like this, and for a couple of reasons. The first reason is that there's resource limitation. Right? Because remember, when you go to the market and you buy a laptop or a desktop, that laptop comes with a CPU, it comes with RAM, it comes with storage. And these resources are designed to work with a single operating system. So when you install another operating system, you have to share these resources. For example, let's say, so I'm just going to use any of this diagram as a RAM. So this is a RAM right here. Now, let's say this RAM had a capacity of 8, and this 8 came with your original laptop. Now when you install a virtual machine, or when you create a virtual machine, you will need to divide this RAM into 2. So you will need to divide this into 2, and your physical machine may have 4 and your virtual machine may have 4, right? So you notice that at some point your physical machine may become slow, right? Because some of the resources are being used by your virtual machine, and you see your machine becomes slow. Whenever you shut down your machine, it takes time for it to boot, come back online, and now you're unable to do different things. And the same thing for storage, right? If you had 1 terabytes of storage, you have to divide that into 2. You have to assign 1 to your virtual machine, right, and leave half to your physical machine. I don't like that, and I just feel like for me that's a disadvantage. Now, the second disadvantage is risks of data loss or corruptions. Now remember that the reason why you are setting up a lab environment is because you want to practice Linux, and we talked about risk-free experimentation, right? When you do it locally, there is some form of risk because you're practicing Linux and something may happen, right? And that may lead to data loss or that may lead to corruption during configuration experiments, right? And I don't think you want that, and I don't think you want to put yourself in that situation. Another one also is limited scalability and isolation, right? So there is limited scalability and isolation, right? Personal computers are not designed for scalable or isolated lab, making it difficult to mimic real-world production environments, right? So in a real-world scenario, companies do not use laptops to deploy applications. They use servers, so they don't use laptops. So when you set up your Linux lab environment on a laptop, it's difficult to mimic. It's difficult to have a feel of how companies are working with Linux servers to deploy their applications, right? So these are just some of the reasons why I'm not a big fan of setting up my Linux lab environment on my lap. So how do you do it? I prefer using the cloud, right? The cloud is my favorite way of setting up a Linux lab environment. And when you're using the cloud, it's pretty straightforward, and all you have to do is you choose a cloud provider, in this case AWS. Then what's next? Create an AWS account, and from there you set up your lab environment in that AWS account, right? And you set up your lab env. And this process is straightforward, and I like it for a couple of reasons. One is that there's nothing like resource limitation when you're on AWS. There's nothing like risks of data loss, because if you do a misconfiguration, you can always destroy that server and you create a new one. And there's also nothing like limited scalability and isolation. With AWS, you can mimic real-world production environments because there are millions of companies out there that are using AWS to deploy their applications. So when you set up your lab environment on AWS, you can mimic real-world production production environment. So how does setting up your lab on AWS works? So the first thing is that you will need to create an AWS account. So you just go to Google and you type AWS free tier account and click on this. Then you now have this AWS free tier. It means when you create your AWS account for the first time, AWS will give you some resources to use for free. Like for example, under compute, you have 12 months free and you have 750 hours per month for free. It means you can launch a server. It can be Linux. It can be any server of your choice for free. It's called the free tier. I'll show you how to choose a free tier server, how to create a free tier server on AWS. So you create one for free and you get 750 hours per month. 750 hours is a lot, right? Linux is not difficult to study. It doesn't take that long to study it. So you won't need 750 hours of time. So hello guys, what's up and welcome back to the channel. My name is Emmanuel Ejijong. If this is your first time visiting my YouTube channel, you're welcome. If you are a returning subscriber or you're definitely welcome as well. So in today's video, we're going to talk about how to create your Linux server. We're going to see how you can launch your Linux server using AWS. In my last video, I talked about how to set up a Linux lab environment. I mentioned in my last video that there are two ways you can use to set up your Linux lab environment. I said one way is using your personal computer or laptop or desktop, and another way is using the cloud. And I mentioned in my last video that the cloud is by far my favorite way of setting up a Linux lab environment to practice Linux. So today we're going to see how to create an AWS account, then use that AWS account to launch our Linux server. So without taking much of your time, let's get started. So the first thing we're going to need is to create our AWS account. So I'll click right here where it says complete sign up, or I'll click here where it says complete sign up. So whether I click here or here is the same thing. I'm going to click here. It's going to take me to a page that looks like this. Once I'm here, it's going to ask me to sign in, but I don't have an account. So I'll click on create new AWS account. Click on that. Then it's going to ask me for a root email address, and I'm going to use this email called labemmanuel5@gmail.com. It's going to ask me for an account name. I'll just call this Linux Lab. That will be the account name. Then I'll click on verify email. So I'm going to say confirm you are you, right? So basically it's going to send me a verification to this email. So if I go here, I will see that AWS has sent me a verification. So I'll click on this, and this will be the verification code. So copy this, come back, put that verification code in here, then click on verify. So as you can see, our email has been successfully verified. Then it's going to ask for a root user password, and it's going to ask to confirm that root user password. So I'm going to put a root user password. Cool. So I just added my root user password, and I also confirmed my root user password. So I'll click to the next step, and it's going to take me right here. So it's going to ask me for some basic personal or business information. The first thing is that it will ask me, how do I plan to use AWS? Do I plan to use AWS, for business that works or within an organization, or do I plan to use it for personal projects? So I'm going to say I'm planning to use this for personal projects. Then it's going to ask me for my full name. So I'm going to put my full name in there. Cool. Then it's going to ask me for my phone number. So I'm going to put my phone number. So that's my phone number. Then it's going to ask me for my address. I'm going to put my address in there. Then I'm going to click on I've read and agreed to the terms of the AWS customer agreement. I'll click on that. Sorry. So I'll click on that. I'll click on continue. So usually what AWS will do is that they will try to verify your identity, and the way they're going to do it, or the way they do it in the US, is that they use your debit card to kind of verify your identity. So they're going to debit $1, then they'll put it back in within 3 to 5 business days. So I'm going to put in this debit card right there. I'm going to put in the month. The month will be July 28. Then I'm going to put in the security code and the name on the card and the address, and I'll click on verify and continue. Nice. So it's going to say sign up for AWS, confirm your identity. So I'm going to say, okay, send me a text message, and I'll put in my phone number, then I'll hit send. And I'm going to click on verify. I think it should be like P8BC7. So they'll send me a security code right on my phone. So I have it right here. That's 8298. I'll click on continue. And now it's going to ask me for a support plan, right? We just go with the basic, that's free. Then I can complete and continue. And now it says, congratulations, you've created your AWS account. So we can now go to something called the AWS console. So when you create your AWS account for the first time, you should see exactly what I'm seeing right here. This is what they call the AWS console. Now, this is not a class about AWS, but it's a class about Linux. So I'm not going to take too much time explaining what the AWS console is. So I will go straight to creating, a Linux server. So as you can see, the first thing I usually like to do is I like to change my region to US East 1. I just like using US East 1, and it takes me, back here. So yeah, what we're going to do is we're going to use AWS to launch our Linux server, the one we're going to use to practice Linux. And in AWS, there's a service which you can use to, create servers, and that service is called EC2, right? Elastic Compute Cloud. So basically, it's a service offered by AWS that makes it possible for you to create virtual machines in the cloud. And in this case, the cloud I'm talking about is AWS. So the way you access EC2 is you can see it on the console home screen, for example, right here. And if you don't find it, you can always come here, click on this, right? And you come to where it says compute, click on that, and you're going to see EC2 right here. Or you can just search for EC2 like that, and you click on this one right here. So right now, as you can see, we don't have any server that's running. So it's important for you to know that a server on AWS is referred to as an instance. So if I'm talking about an instance, know that I'm referring to a server, right? So as you can see, we don't have any server that's running at the moment. So we would need to create one, and that's exactly what I'm going to show you how to do. So click on this right here that says instances. Click on that. As you can see, we don't have any instance that's running. I want you to click right here where it says launch instances. Then this is where we're going to create our instance. Now, if you're new to Linux, you're new to IT, I don't want you to feel overwhelmed or panic. Just follow, my steps. The first thing is that it's going to ask you for an instance name. So I'm just going to call this lab server. That's how I'm going to call it, lab server. Then it's going to ask you for an application and OS image, right? OS means operating system, right? There's something on AWS called Amazon Machine Images. So you can basically just read about them here. But I'll dive deep into this when I create a course on AWS. So when I create a course on AWS, I'll dive deep into what Amazon Machine Images are. So for now, don't worry about it. So what I want you to do is I want you to come down here and I want you to click on Ubuntu, right? And remember that Ubuntu is a Linux, it's a type of Linux distribution. If you don't know what a Linux distribution is, there's a video on my channel where I talk about what Linux distributions are, and I also talk about the 7 best types of Linux distributions that exist. And the first one I mentioned is Ubuntu, and that's the one we're going to use. So choose Ubuntu. Then where it says Amazon Machine Image, I want you to make sure that it's on free tier eligible, right? So make sure that it's on free tier eligible. So I'm going to click on that, right? Then I want you to go down, and where it says instance type, so you're going to leave everything here as default, right? Then where it says instance type, I want you to choose T2 micro. As you can see, free tier eligible. Now it's going to ask you for a key pair, right? Or a login. So basically a key is like a password. Without a key, you cannot log in into this server you're creating, right? And I'm going to show you how to use that. As you can see, we don't have any key. So what you want to do is you want to click on create new key pair. So you want to click on that and you want to give your key pair name. So I'm going to call mine Linux lab key, something like that. And the key type will be RSA. Leave leave it on that. Private key file will be .pem, so you want to leave it on that as well. Remember, I'll explain all of these when I create a course on AWS. This is not a course on AWS, rather it's a course on Linux. So put this right here. Make sure you have RSA. Make sure that the private key file format is on .pem and click on create key. As you can see, our key is right here. So our key is around download. So what I usually like to do is I'll just drag this and have it on my home screen, then I'll go back. So this is the key that we're going to use to log in into our server. Then it's going to ask us to do some network settings. Ignore everything here, ignore everything, and click on launch instance. It says successfully initiated launch of instance. So you can click on this instance ID and it's going to take you right here. So as you can see, this is the name of our server. It's called lab server. This is what they call the instance ID, and this is the instance state. So as you can see right now, it's running, right? And this is the instance type. It's a T2 micro, and it says status check is initializing. And what we're going to do is refresh this until we get to a point where everything is fully checked. So I'll just refresh by clicking here. I'll refresh one more time. As you can see, it's taking some time to initialize, but that's fine. The one thing you can do is just click on this instance and it's going to take you right here. So here you have instance summary for this is the ID of our instance and this is the name of that instance. Remember that instances on AWS are servers, right? It's just another name for a server. So right here we're going to have the instance ID or the server ID. Then we're going to have the public IP address of our instance, and we're going to see the state of our instance that's running, right? And if you browse through this page, you can get a lot of information about this server. So what we're going to do next is we're going to connect to this server, right? So to connect to this server, I want you to come right here to where it says connect, right? And if you're here, you can just select your server and you can click on connect, or you can come right here and you click on connect. So you click on connect, it's going to take you to a page that looks like this. So there are different ways you can connect to an EC2 instance. So you can do what they call an EC2 instance connect. You can do a session manager, or you can do SSH client. So we want to do SSH client. So in my next video, I'm going to talk about what SSH is and how SSH works and how you can use it to connect to your EC2 instance. But let me just show you how it works here. So I'm going to click on SSH right here, and what I will then do is I will need something called an SSH client. I'll talk about what an SSH client is in my next video, so don't worry about it. And for this case, my SSH client would be my terminal. So I will put my terminal right here. I'll click on that and I'll expand this. I'll make this bigger so you can see. Hopefully you can see. Then what I'm going to do is I'm going to use this to SSH. So the first thing that I'm going to do is I'm going to do SSH space. Then I'm going to put the username of the server. As you can see, our username is, hold on one second. This is our username. Our username is Ubuntu right here. So I'm going to copy Ubuntu and I'm going to put Ubuntu right here. I'm going to put mention, then the IP address of the server. So if I go back here and I click on this and I put that IP address right here and I hit enter, this is not going to work, right? And I do yes. So this is technically not going to work, right? Because remember that when we created our instance, or when we were creating our instance, we specified that we wanted to use a key to log in, right? So we wanted to use a key to log. So as you can see right here, it says permission denied, public key, right? So we have to provide that key in order for us to log in. So the way you provide that key is you would do, first of all, let me do an LX. Don't worry about what LX is, and I just want to make sure that I go where that key is. Remember that that key is right here on my desktop, so I have to go to my desktop. As you can see, this is my desktop right here. So if to go to your desktop or to go to download, maybe your key can be under download or it can be on desktop. If you drag it to your desktop, you'll find it on your desktop. If you put it in download, you'll find it in download. So now do not worry about what all of this is. In my next video, I will explain all of this in detail. So what I want to do is I want to go to desktop. So in order to go there, I'll just do cd, then I'll do desktop right here and I'll hit enter. Then if I do LX means list. You will now see that if we look carefully, we should see that key right here. So this is that key right here called the Linux lab key, right? So and you can confirm by saying it here, the Linux lab key. So what we want to do now is that we want to SSH back. So we can still attempt to run this command like this, right? But still it's not going to work because we have to pass that key in here. We have to provide that key. The fact that we've gone where that that key is. So as you can see, the key is right here. Doesn't mean that you can just use it. So you still have to, that key right there. So, and the way you do it is extremely simple and straightforward. So I'm going to do SSH. Then I'm going to do SSH-I. I stands for identify. Then I'm going to provide that key, which is this one right here. So I'll copy this and I'm going to paste this in here and give it some space. Then I'll hit enter. Now it's going to say warning, unprotected private key file. That's fine. Come back here and you copy this. Don't worry, I'm going to talk about what this is in Linux. That's just to change file permission. Don't worry about it. I'll talk about it. Then you will paste that in here and you will hit enter. Then you will run this command one more time. So you can copy out of this, paste it right here, and you hit enter one more time. And boom. So as you can see, now we are inside of our, Ubuntu server, or we are inside of our server. So for example, here I can run commands like sudo app update, and you will see it will start updating the server, right? So give it some time. Nice. So as you can see, it's up to date. I can also do a couple of things. For example, I can type commands like, date. Boom, it's going to provide me with the date. And I can type, different commands like ls. I can type commands like pwd. Don't worry about what all these commands are. I will, talk about this command in our next video. So guys, that's how you create your AWS account. Then you use that AWS account to launch your Linux server. And we're going to be using this Linux server to practice Linux. So in my next video, I will dive into what SSH is. I'll explain, what SSH is, so that you have a better understanding of how to SSH. I'll also show you different SSH clients that you can use to, to SSH. So now, before you leave, I want you to go back to AWS, click on instance, then right click on instance state. I want you to stop it. So come here, click on this, click on stop, and click on stop instance and refresh. As you can see, is stopping, and in less than 30 seconds this instance will stop. So guys, thank you guys for watching. Please do not forget to like, share, and subscribe to this video. See you in my next video. Bye. So in today's video, we're going to talk about what SSH is and how to use it to connect to a remote server. So we're also going to see why SSH is important. I know that this is not a networking class, rather it's a class on Linux, but I feel like it's important for you to have an idea of what SSH is. So without taking much of your time, let's get started. So first thing first, what's the meaning of SSH? The first thing I want you to know is that SSH stands for secure share or secure socket share. If someone comes to you and say, hey, I want you to use secure share, or I want you to use secure socket share, know that that person is talking of SSH, right? So the full meaning of SSH is secured share or secured socket share. So what is this secured share we're talking about, or what is this SSH we're talking about? The first thing I want you to know about SSH is that it's a network protocol. That's the first thing. So basically, SSH is a network protocol that allows two computers to communicate together over an unsecured network. And the unsecured network we're talking about in this case is the internet, right? Let's say you have a server, and this server is located somewhere in the United States. And let's say you are in Africa, right? So you've created your server in the United States and you're somewhere in Africa. There are two ways you can connect to this server. The first way is you can physically go where this server is, and you can plug in a keyboard and a monitor and you can connect to this server physically. That's what they call the console connect. But since you're in Africa, that's not going to happen, right? So you have to remotely connect to this server right here. So in order for you to be able to remotely connect to this server, you will need an internet connection. So you need to go through the internet, meaning that you would connect to the internet, then from the internet you will connect to that server. But here's the thing, the internet is not secure. The internet is not secure, meaning that there can be a hacker somewhere online just observing what's happening online and trying to find something interesting they can use. And when you connect to the internet that's not secured, in order to connect to your server, this hacker right here can steal your information. They can steal your username, they can steal your password, and they can even steal the IP address of your server. And they can also use that to connect to this server, and they can use the server to do crazy things. Like, for example, they can delete your entire application, or they can use it to mine Bitcoin. So there are different things that this hacker can use the server to do. So since the internet is not secure and you cannot physically go where this server is, how do you connect to this server? And that's where SSH comes in. So what SSH SSH does is that SSH kind of secures your communication with this server. So what SSH is basically a network protocol that allows two computers to talk together. So this computer right here, we talk with this computer right here in a secured way. And the way SSH does is by encrypting this communication. So right, is by encrypting this communication. So whatever thing you're doing on this, server, this guy right here cannot see, right? Thanks to SSH. Now, SSH, as I said, will allow you to connect to this server. And once you connect to this server, you can do things like run commands, you can do updates, you can install software, and you can even transfer files from one server to another. So that's kind of what SSH is. It's simply a security measure for you to connect and talk to your computer without a third party seeing what you're doing. I guess you're asking yourself now, Emmanuel, how do I SSH? In order for you to SSH, there's some requirements that you must meet. The first one is you must have a server, right? That obviously makes sense. You must have a server. If you don't have a server, you cannot SSH. You must have something called an SSH client. So what is an SSH client? An SSH client is a tool or a piece of software that provides an interface for users to SSH, right? It's a tool. It's just a tool that enables SSH, right? And I'm going to show you how to use these tools in order to SSH. And there are a couple of SSH tools out there. You have PuTTY, which I'm going to show you how to use. You have OpenSSH, you have Mobile XTEM, and you have a terminal if you're on Mac or Linux. So if you have a MacBook or you have a Linux computer, you can use the terminal on your Linux computer to SSH, and I'm going to show you how to do it. But if you have a Windows computer, you can use PuTTY, and I'm going to show you how to use PuTTY. Now, apart from having a server, having an SSH client, you're also going to need to know the username on the server. What's the username on this server, right? When you want to log into your Instagram account, Instagram will ask you for a username, right? So without that username, you cannot log in. It's the same thing for this server. If you want to log in into this server right here, you will need to know the username of this server, right? What's the username of the server? Is it Ubuntu? Is it root? Is it John? Is it Emmanuel? Is it Peter? What is the username of that server? So you would need to know the username of that server. Now, apart from knowing the username of the server, you also need to know the password of that server, right? Let me ask you this question. If you have just the username of your Instagram account, can you log in? No, you also need the password. It's the same thing for this server. If you have just the username, let's say the username is Ubuntu, but you don't have the password, you won't be able to log in. So you also need to know the password. Some servers do use keys, right? If you don't have the password, you would need a key in order to log in, and I'm going to show you how to use the password and how to use a key to log in into your server. You also need something called the host name. The host name can either be an IP address or it can be a domain name, and I'm going to show you how to log in with an IP address, and I'm also going to show you how to log in with a domain name. Right now, apart from having all of these things, a server, SSH client, the username, the password, the host name, there's something that's extremely important that you will need. Remember that we said that SSH was a network protocol that allows two computers to talk together over an unsecured network, and we said that unsecured network is the internet. And the way SSH does is by encrypting the communication between these two computers so that a third party person cannot see it. But there's also something that's extremely important in order for this to happen. A specific port has to be open on this server, and that's port 22. Port 22 must be open on this server. If port 22 is not open on this server and you have all of these things, sorry, you cannot SSH. SSH is not going to work if port 22 on this server is not open. That's why as you're learning Linux and you're launching servers on AWS to practice Linux, there's one thing I want you to do. Do not mess up with your network configurations, because if you do, you may likely shut down this port 22 without you knowing. So make sure that when you get to where it says network setting, just leave it as it is, move to the next step, launch your server, and use that server to practice Linux. So these are the things that you will need in case you want to SSH. So let's do less of the talking and let's do some demonstration. Okay, so back here on my computer, I have two servers. I have one server on this cloud provider called Linode. I think they've rebranded into Akamia, but I just love calling them Linode. And I have another server right here on AWS, right here, this server right here. So we're going to see how to SSH into this server. So the first one we're going to, see how to SSH into will be this one called Linux. Now remember I said that in case you want to SSH, you're going to need an SSH client. So without an SSH client, it's not going to work. And I said an SSH client can either be PuTTY, or you can use your terminal if you're on Mac or Windows, or you can download and install either OpenSSH or MobileXterm. Now for this first example, we're going to use PuTTY as our SSH client. Now remember that I'm on Mac, and PuTTY is not the ideal SSH client when you're using a MacBook Pro or a MacBook Air, right? But it's great for people that are on Windows. The other reason why I want to use it is because I want to show people that are on Windows how they can use PuTTY in order to SSH. And I'm also going to put links below this video so that you can go and download PuTTY and install it in case you don't have it. It's straightforward and it's easy to install. So I'm going to come here and I'm going to type, hopefully you can see that. So I'm going to come here and I'm going to type PuTTY and I will hit enter and boom. So this is PuTTY right here, right? Now, the way you get access to PuTTY on a Mac is different from the way you will get access to it if you are on a Windows machine, right? On a Windows machine, you will just click on it on your desktop and it will open. But here you have to use the terminal to get access. That's why PuTTY is not the ideal solution for someone that's on Mac. So in order for us to SSH, PuTTY is going to ask us for a couple of information. The first is that they're going to ask us for a host name. Remember I said a host name can either be a domain name or it can be an IP address. Now in the case of this server, what we have here is an IP address. So I'm going to copy this IP address and I'm going to paste that IP in here. Then I'm going to hit open and it's going to take me to a page that looks like this. So the first thing that PuTTY is going to ask me is login as. Remember I said in order for you to SSH, you must know the username of the server. So if you don't know the username of that server, you cannot SSH into that server, right? In this case, our username will be root. I'm going to hit enter. Then it's going to ask me for a password. Now this specific example does not require a key, but rather it requires a password. Then I'm going to put in the password and I'll hit enter. Boom. As you can see, now we are inside of that server. For example, I can do a sudo app update and I hit enter. As you can see, it will start updating. So that's how you use PuTTY to SSH into your server. It's straightforward and it's very, very simple. So if you're using a Windows computer, you can use PuTTY to SSH into your server. So I'm going to type exit to log out. Then what I want to do is I want to do the same thing, but this time I want to use a terminal. I'm not going to use PuTTY, but I'm going to use a terminal on Mac. And the way you access a terminal on your Mac is pretty simple. You come right here, then here you type terminal, you select this terminal and this will show up, right? Let me expand this. I think this is good. So I'm going to expand this like this. Hopefully you guys can see. Expand this one more time. Okay. So on your terminal, instead of using a graphical user interface like PuTTY, where you basically just put in your IP address and you ask for a username and a password, here you have to type everything. So for here, I'm going to type SSH dash the user. In this case, the user is root. I'm going to type @ then I'll put in this IP address. I'll copy this IP and I'll put this IP in here. I'm going to hit enter. I'll say yes. Then it's going to ask me for a password. So I'm going to put a password and I'm going to hit enter right here. Boom. So as you can see, now we are inside of that Linux machine, or we're inside of that Ubuntu server. And even here I can do things like, for example, I can do cat etc/os.release and I'll hit enter and it will basically just give me some information about the server. Like for example, this is the version of Ubuntu that we're running, right? The operating system here is Ubuntu. Remember that Ubuntu is simply a type of Linux distribution, right? So guys, that was how to SSH using a username, an IP address and a password. Now let's see how to SSH using a key instead of a password, right? Let me hit exit, clear my screen. And in order for us to SSH using a key instead of a password, we're going to need to use AWS. So let me quickly, so I'll go where AWS is right here. And this is the server we're going to SSH into. So I'm going to grab this server. As you can see, this is the IP address right here, right? So I'm going to copy this and I'll come back here. And I'm going to do SSH. The user will be Ubuntu. I'm going to put in the password. I'll hit enter. I'm going to say yes. As you can see, this is not going to work, right? Remember when we tried to do that with Linode, it actually asked us for a password. But when we're trying to do it with AWS, it's not working because remember our server on AWS is not configured to use a password, rather it's configured to use a key. So we have to provide that key. And in order for you to provide that key, so you need to use an option. Like for example, I'm going to say SSH-I. I in this case is the option. I stands for identity file. Then I'm going to provide the name of the file, or the name of the key is linuxkey.pem, and I'm going to provide the user, that's Ubuntu, and I'm going to provide that IP address one more time. I'm going to grab this IP, I'm going to put that IP in here, and I'll hit enter. Now it says permission denied, right? Now the reason why it's saying permission denied is because even though I've passed this key in here, my server still cannot find this key in my current directory. So if I do, for example, LX means list, don't worry about what LX is, and I start looking around, you're not going to find that key here. Why? Because that key is right here on desktop, right? So the key is right here on my desktop. So this is the key right here on my desktop. So I can do a couple of things. I can do, for example, I can do pwd, and don't worry about what pwd is, I'll talk about it. And I can say, oh, okay, my key is on my desktop right here. The cd into desktop. Don't worry about what cd is, I'll talk about it. Hit enter. I'm going to clear my screen. Clear. Don't worry about what clear is, I'll talk about it. Hit enter. Then I'll do LX. And if I look carefully, I'll see that key here. So there are two things I can do. One is I can SSH directly from here, right? I can just SSH from here and it's going to work. Or another thing is that I can do pwd and I can copy all of this and I can go back, so I can do cd dot. Don't worry about what cd dot is, I'll talk about it. I'll hit enter, and in here I will look for that SSH command that we try to run, which is this command right here, and I will come somewhere around here and I will paste this in here and I will put a slash here. Don't worry about it. I will talk about what this is when we dive into we dive deep into Linux. Then I would then hit enter, and boom. So now you can see I'm inside of that server, right? I'm inside of that server. So what I simply did here is that I told my server that, hey, go to this path right here, go to this place right here and look for that key, then use it, right? And now you can see we're inside of the server. So I'm going to exit, and if you don't want to do it that way, let me clear my screen. You can always do an LX. You find where your key is. Maybe it's on download, maybe it's on download right here, or on desktop. Then mine is on desktop. Then what you would do is you will cd to desktop, clear your screen, you do an LX, and you'll find that key here, and all you have to do is to run again that command one more time. So I'm going to run that command one more time, but using this, we don't need this. Then I will hit enter, and this time is going to work. Why? Because we are in the directory where that key is. Now let me say it again. Do not worry about what directories are. Do not worry about what all these commands I'm running are. We'll definitely talk about it. Now, as you can see, we are inside of the server, and I can do things like sudo app update, and it will start updating our server. All right, our server is up to date. So that was how to log in on an AWS instance or an AWS server using a key and an IP address. Now let's see how to log in using a domain name, right? So I'm going to exit, and to log in using a domain name is very simple. Just come here on AWS, go to connect, then come where it says SSH. Are you seeing right here? AWS provides you with the command already. So just copy this, come back here, put it in here, hit enter, and right here is the domain right here, right here is the domain. As you can see, this is not an IP address, rather this is a domain. Then hit enter, say yes, you want to log in, and boom, see, we've logged in into that server, right? And if you were not in the part where your your key is. For example, let's say pwd. Don't worry about, cd dot dot. Don't worry about what cd dot dot is. I'll clear and I will do a pwd. As you can see, we're here and we know that our key is not here, because if I do ls, you cannot find that key here. We know that our key is inside of desktop. So I'll do cd to desktop. I'll clear my screen. I'll do ls. Our key is right here. I'll do pwd and I'll copy this right here and I will do a cd dot dot. Don't worry, I'll talk about what cd dot dot is, and I will attempt to SSH one more time and I will come back here and I'll hit enter and boom. As you can see, we're inside of the server, but we are not where that key is, but we're inside of the server. Don't worry, I'm going to talk about all of this. This is going to make a lot of sense, but what I want you to know is how to SSH. And right here I can do things like sudo cat etc/os.release. I'll hit enter. Sorry, this is not the right command. I'll hit enter. As you can see, it's going to provide us some information about this server as well. And I can also do things like sudo su, and I can switch to to the root user. Don't worry, I'm talking about what sudo su is. So guys, that's what SSH is, and that's how to use it to connect to your remote server. Now, I don't expect you to have a mastery of this in the beginning, but what I'm going to say is that as we progress through this Linux course, each time you're done practicing Linux, terminate your server, meaning that come here on AWS, click on this and click on where it says instance state and terminate this instance, and come. If you're using Linux, I guess you're not, but just make sure you come here and you terminate the instance as well. So I'm going to copy this, put this in here, and I'll hit delete. Cool. So make sure you delete or terminate your instances each time you're done practicing Linux. Why? Because the following day, if you want to practice Linux, you'll be forced to launch another instance. So you'll be forced to SSH into that instance, and that's going to help you to practice how to SSH, practice how to log in into your remote machine all the time. So that's it. So guys, thank you guys for watching this video. Hope you guys now have a better understanding of what SSH is and how to use it. In our next video, we're going to talk about the Linux, the Linux terminal. For example, this terminal, this thing you're seeing right here, what is it? In our next video, we're going to talk about it. Thank you guys for watching. Please do not forget to like, do not forget to share, and do not forget to subscribe to my YouTube channel. See you in my next video. Bye. Hello guys, what's up? Welcome back. Yes, your guy Emmanuel Ejichong, and thank you for checking out this video on the Linux UI. So if this is your first time on my YouTube channel, I want to say thank you. But if you are a returning subscriber or viewer, I also want to say thank you. So in today's video, we're going to talk about the Linux UI or the Linux user interface. If I mention UI, know that I'm talking of the user interface. So each time I use the word UI, please just know that I'm talking of user interface. So today we're going to talk about the Linux user interface, right? So each time you will log into your Linux server to practice Linux, this is the interface that you're going to see. Basically, you're going to see this text and you're going to see a dark screen. So what is this interface, right? What is this dark screen? And most importantly, what is this text? In this video, I'm going to explain that. So without taking much of your time, let's get started. So first thing first, what is the meaning of a user interface, or what is the meaning of a Linux user interface, right? So the Linux user interface is how you interact with the Linux operating system, right? It's how you communicate with the Linux operating system. So there are two types of Linux interface. The first one is what they call a graphical user interface, right? That's the first one. And with a graphical user interface, everything is visual, just like in Windows or Mac OS. For example, I have a Mac computer, and if I want to interact with my operating system, this is the interface that I'm going to use. As you can see, it's beautiful. It has colors, it has pictures, it has icons I can click on, right? For example, if I want to see all my applications, I can click here and it will take me right here. I can go to Finder, I will see this organized, well structured folder, and I can go into application applications, I can go to desktop, I can go to documents. If I download something and I want to see, I can go to download right here. If I want to log out, I'll click on the Apple icon and I'll click on log out right here. So as you can see, this is what they call a graphical user interface. In a graphical user interface, you would have windows, icons, buttons, and you have a mouse to be clicking around, right? And Linux also has this type of user interface. For example, if you install Ubuntu on your desktop, you can install a graphical user interface, right? Now, apart from having a graphical user interface, right, Linux also has something called the command line interface. Remember I said when you're dealing with Linux, there are two types of interface. One is the graphical user interface, and the second one is what they call the command line interface. And the command line interface is a text-based type of interface. So instead of clicking around and using your mouse and going around and you're seeing beautiful colors and all the rest, in the command line interface, you use commands. So basically, if you want to do something, you would write a command and Linux will execute that command, right? As you can see, it's just a black screen with some text right here. Now, don't worry, we're going to talk about what this text is, but I want you to know that what you're seeing right now is a command line interface. Now, when you become an engineer, whether you're a cybersecurity engineer, DevOps engineer, system cloud engineer, and you get your first job, there's a probability that you may hear some of your co-workers refer to this here as a CLI. So if they're talking about a CLI, know that they're talking about what? They're talking about the command line interface, right? Now, the command line interface uses something called a terminal. What you're seeing right here is a terminal, and a terminal is simply a black screen. Now, listen, I'm going to give you the book definition of what a terminal is, but what I want you to know right now is that a terminal is simply a black screen where you type instructions, right? And that's what we are looking at right now. For example, I can type LX. For example, I will hit enter. Nothing is going to show. I can type, for example, date, and you can see it's going to return the date. And if I want to clear everything, I can type clear and it's going to clear everything. So that is how, a command line interface works, right? Now, I know you'll be asking yourself this question, but Emmanuel, why is it that Linux has two interfaces? Now, the first thing I want you to know is that Linux was developed for advanced users, right? Linux was developed for engineers to use, not the ordinary person, right? And they developed this command line interface because the command line interface is way powerful than a graphical user interface. And I'm going to show you how powerful the command line interface can be. But later on in the development, some extremely smart guys said, hey, this command line interface is kind of challenging for some people, especially people who are transitioning from Windows and Mac OS into Linux. So they decided to develop what they call a graphical user interface for Linux. But I want you to know that all the big companies out there, they use a command line interface. Graphical user interface in Linux are used in personal computers. All those massive data centers, they are using command line interface to manage them, right? And this is what they call a command line interface. This whole thing right here is what they call a terminal. And this is the only text that you will see when you log in into your server. So what is a terminal, right? I said what you're seeing right here is a terminal. So what is a terminal? A terminal is a tool or a program that lets you interact with a computer by typing text commands instead of clicking on things. For example, here on a graphical user interface, if I want to go to applications, right, I'll have to click on Finder, then I'll have to click on Application. Now, in a command line interface that uses a terminal, you don't click, you type commands, right? So for example, if I want to know the date, I'll have to type the command date, right? But in the graphical user interface, it's not like that. If I want to know the date, I'm going to see, the date right here. But in Linux, you would have to type a command in order to see the date. So this is how, a terminal looks like when you log into Linux or when you log into your Linux server. So this is what you're going to see. Basically, let me clear my screen. So basically, what you're going to see would be a dark screen or a white screen. It depends on you, and some text. So the question now is, what is this text? Don't worry, I'm going to explain to you what this text is. So So this text right here is what we call the shell prompt in Linux. Now the question is, what is a shell prompt, right? Now a shell prompt in Linux is the text or symbol displayed in a terminal window that indicates the system is ready to receive a command. So when you see this right here, you have to know that your Linux system is ready to receive a command, and all of this is what they call a shell prompt. Now let me explain this shell prompt right here. Right here, what you're looking at right here is the user. So this user right here is Ubuntu. So I'm currently logged into this server with a user called Ubuntu. For example, if I go to my Mac and I click on this icon right here, I click on systems settings, you're going to see that right now I'm logged into my Mac as Emmanuel Gijo, and this is my email right here, and these are all the devices that are connected to this Mac, right? And if I still click on this icon, you'll see that I can log out as Emmanuel and log in back as another user. Same thing with Linux. In Linux, I'm currently logged in as Ubuntu, and I can also ask Linux to tell me what user am I using, right? For example, I can say who am I, and I hit enter, and it's going to say I'm Ubuntu. If I was logging as another user and I put who am I, it's going to return the username of that user. So for now, when I run the command who am I, it says I'm Ubuntu. So the next thing you have right here is something that looks like an IP address. This is what they call a host name, right? This is the host name, and the host name here is the name of the computer. And you can also run a command and Linux will tell you exactly what your host name is, and that command is simply host name. Now don't worry about what commands are. I'll make an entire video explaining Linux command. So when I run the command host name, you will see that Linux returns the host name of the computer. And when I run the command who am I, Linux returns a response by saying I am Ubuntu. It's like asking someone what is your name. So what I'm basically doing with this command is I'm asking the computer what is your name. I'm asking my Linux operating system what is your name, and the Linux operating system is responding back to me by saying I am Ubuntu, right? My name right now is Ubuntu, and I'm asking, what is the host name, what is the name of the computer, and the operating system is returning a response to me, with this right here. So this right here is the username, and this right here is the host name, and the host name is the name of the computer. So I'm currently logged into this computer as Ubuntu, or using the username Ubuntu. Right now, right here we have something right here, and this is what they call the current working directory, right? And this sign right here, let me make it bigger so you can see, and this little sign right here, right, represents what they call the user's home directory. Now don't worry, I'm going to talk about what directories are, but I want you to know that this right here represents the user home directory right here. This is the user home directory. Now in front of this, you're going to see a $sign, right? This $sign simply indicates that the user that's currently logged into this server, that's Ubuntu, is a regular user. So whenever you see a $sign, right, in front of a shell prompt, know that the user is a regular user. Now, but when you see a $sign, know that that user is root. I know you're asking yourself, Emmanuel, what are you talking about? What $sign are you talking about? So for example, if I change users, if I do a sudo so and I hit enter, you're going to see that my user now is root. It means I'm now logged into the computer, or the user that I'm currently using is root. And you're going to notice that this sign right here has changed into a $sign. It's no more a $sign. It's now a $sign. And whenever you see a $sign, it means that the user that's currently logged into this computer right here is root. And root is the most powerful user in Linux. Don't worry, we're going to talk about what users are, right? But if you see a $sign right here, know that this means a regular user. Only root has this $sign. For example, let's say the user was John will still have the $sign. If the user was Mary will still have the $sign. If the user was Paul will still have the $sign. But immediately the user changes to root, the $sign will change to a £sign. Only root has a £sign. So whenever you see a £sign, know that the user is root. So I'm going to switch back to Ubuntu. So I'm going to do su-ubuntu. I'm going to hit enter. Sorry, I didn't run that correctly. And I'm going to hit enter. So as you can see, I'm back Ubuntu, and as you can see, the $sign is back, right? So let's take this one more time so you understand exactly what we're seeing. This is what they call the Linux terminal, and the terminal is simply a tool or a program that allows you to interact with the Linux operating system by running commands. And this right here is what they call a shell prompt, and a shell prompt is simply what indicates that your Linux operating system is ready to start receiving commands, and when you give those commands, Linux will execute those commands. And the first thing you see here is what they call the user that's currently logged into this server, and in our case it is Ubuntu. And what you have next is what they call the host name. The host name is the name of the computer, and what you have here is what they call the current directory, and this small sign right here is what they call the user home directory, and this is what they call the prompt sign, and the $sign means that it's a regular user. And if you switch to root, it's going to change to a £sign, and only root has a £sign. Don't worry, we're going to talk about what users are, and you will know the difference between a regular user and a user like root, so don't worry about it. So this shell prompt right here is very, very important. The first thing is that whenever you see this shell prompt, know that your Linux server is ready to accept commands. It means I can start running commands like ls, I can do pwd, right? I can do cd, right? Even though there's nothing to cd into, I can do, for example, man, I can run the man command. So this is actually a command, but it says what manual page do you want? So I can run commands like man, right? And it's going to provide me, with some information, right? Now, as you can see, our shell prompt is gone. So there are times you may be working with Linux and your shell prompt right here will go. So all you need to do is hit Ctrl Z and you will get your shell prompt back like this, right? So I can clear my screen. Clear is also a command to clear everything that's on your screen. So I can clear, enter, and it will take me back here. So guys, that is the Linux user interface, and this is the interface that we're going to be using, right? Remember that this is what they call a shell prompt. This is the current user that's logged into the server. This is the name of the server, and this is our present or our current home directory. This is our user's home directory, right here. And right here, this is a special folder that contain things like users personal file settings, and a bunch of data are stored here. Don't worry, when we start exploring the file system in Linux, we're going to understand this better, right? So guys, that is all I wanted you to know about the Linux user interface. Please, if you do have any question, please do leave a comment below and I'll be more than happy to answer you. See you in my next video. Bye. Hello guys, what's up? Welcome back. Yes, again, Emmanuel Ejijon, and in today's video we're going to talk about the Linux file system. This video is very important for anyone who wants to understand Linux. Why? Because the Linux file system is the whole of Linux. It means you cannot do anything in Linux without using the Linux file system. And if you can understand what the Linux file system is and how to navigate the Linux file system, I would say you're 80% done with Linux, and the remaining 20% is just for you to master the Linux commands and understand how to use it to navigate the Linux file system. Okay, so what is the Linux file system? A Linux file system is a method of organizing and storing files on a Linux operating system. The two things that I want you to remember from this definition is that the Linux file system organizes and store files on the Linux operating system. So it's a method of organizing and storing files on the Linux operating system. It says it uses a hierarchical structure with all the files and directories branching out from a single root directory. This is another thing that's very, very important, allowing users to access data in a structured manner. Remember, the Linux file system is simply a way that the Linux operating system organizes and stores files on the Linux operating system, right? And it says here that it uses a hierarchical structure whereby all the files and directories branch out from a single directory known as the root directory. Now, another thing you have to know is that there are different types of Linux file systems in the market, but the most commonly used type of Linux file system is one called the ext4, and ext4 stands for the fourth extended file system. So it stands for the fourth extended file system. So that's what ext stands for, and this is the most commonly used file system in the market. And basically, this is an iteration of the extended file system family, and this specific file system is way better than the previous file systems that were in the market, like the ext2 and the ext3. The ext4 file system offers better performance, reliability, and scalability. So as a result of this, it's one of the most used file systems in the market. So a file system, let me repeat this once again, is simply a method used by the Linux operating system to organize and store files on the Linux operating system. And all the directories and the files that are stored on the Linux operating system, right, branch out from a single directory known as the root directory. So as you can see, this is a diagram of the Linux file system, right? And as you can see up here, the first directory in the Linux file system is this directory here called root. And I said root is represented by a slash sign, which is this, slash sign right here. And under root, you would find different directory. You will find the slash bin directory, the slash etc directory, the slash sbin directory, the slash usr directory, the slash var directory, and you also have some commonly used directories like dev, home, lib, mount, opera, and root. Now you will notice that there are two types of root directory. There is this root directory right here, and there is this other root directory right here. I will explain the difference between the two. So this is how the Linux file system looks like. It means that if I go on my Linux server, I'm going to see a file system that looks exactly like this. So right here, I'm on my terminal. I'm sure by now you know exactly what a terminal is and what it does. If you don't, please go watch my previous video. So right here on my terminal, if I want to go to my file system, I'll have to do a cd. Don't worry about what cd is, but cd stands for change directory. I'll explain it. I'll make a separate video explaining the commands that you will need to navigate the Linux file system. So I'll have to do a cd slash. Why? Because remember that the file system is a slash, right? So I have to do cd slash. I'll hit enter. Then now if I do an ls, don't worry about what ls is. You see, it's going to show me some files right here. And if you look carefully, you're going to see that these files right here, like the bin, the etc, the ops, the sbin, the dev, the home, the mount, the root, prod ops, all of this, even the var, all of these directories that you see right here are the same as these directories that you see right here. So this is just an indication to let you know that right now I'm inside of my Linux file system. And when I define the Linux file system, I said that the Linux file system was a method used by the Linux operating system to organize and store files on the Linux operating system. As you can see, everything is organized. You have directory called bin, you have a directory called etc, you have a directory called media, root, home. As you can see, every single thing right here is organized, meaning that it's easy to access this data and use this data to do specific things. Now don't worry, we're going to talk about what each of these directory does. Like for example, what is the use of the bin directory? What is the use of the etc directory? What is the use of the home directory? What's the use of the root directory? And why is it that there are two roots, right? What's the difference between the two roots? What's the difference between the root that's just a slash and the actual root that's like this? So what's the difference between the two? So as you can see, this is the file system right here. Now let's kind of understand two important things when it comes to the file system: hierarchical structure, right? The first thing I want you to know is that the Linux file system is organized as a single tree hierarchy with the root directory at the top, right? So if we go back to our diagram right here, you're going to see that the root directory is at the top, right? And that's kind of what this explanation is saying right here. It's simply saying that the Linux file system is organized as a tree in which, the root directory is at the top. Everything starts from the root directory and branches out. So if we go back to our diagram, you're going to see that everything here starts from root, then it branches out to different directories. For example, it branches out to the /bin, and inside of /bin, you now have different files. All of these are files, and we're going to go inside of the /bin and we're going to explore all of these files. Okay, so I keep talking of directories and files. So what is a directory in Linux and what is a file? Directories are like folders that contain files and other directories. So basically a directory is simply a folder. So what you call on Windows and Mac that folders, on Linux they're called directory. For example, right here on my desktop I have a folder. In Linux it's known as directories. So whenever I use the word directory, simply know that I'm referring to a folder. Now a file in Linux can be a regular file, or it can be a special type of file, like for example device files, or it can be a symbolic link. Don't worry, we're going to talk about that as well. Now when we're navigating the Linux file system, there are some specific directories that we're going to navigate. As you know, we cannot navigate the entire Linux file system because there are a lot of directories right here, and you will not use all of these directories when you're working on projects, right? There are directories that you will never touch, but it's good to know exactly what they do, but you will never touch them. You will never change something there. So I picked a couple of directories that we're going to navigate when we are exploring the Linux file system. And the first one is definitely the / directory, which is actually the root directory of the file system. And we're also going to look at this directory right here called the /home directory. Basically this is the user home directory. Then we're going to look at the directory called etc. This directory contains all the configuration of our Linux operating system. So we'll go in there, we'll see different configurations that are in there. So we're going to look at two directories. We're going to look at a directory known as the /bin, and we're also going to look at another directory known as the sbin, right? These two directories are extremely important. Why? Because they contain binary executables of all users and administrators, right? Without these two directories, I cannot run a command on the Linux operating system. So these directories are the directories that manage commands on the Linux operating system, and we're going to go in there and we're going to see the different files that are inside of this directory and the use of those files. Then we have the /var directory. For example, this contains variable files such as the log files and databases. So for example, if something happens to your server and you want to troubleshoot and fix it, you have to go inside of this directory. Then you look for the logs to have a better understanding of what happened so you can fix it. Then we're also going to look at another directory known as the temp directory. Basically it's a directory used to store temporal files. So if you have a file that's temporal, you don't want to keep it for long, you can put it in this directory. Then we're going to look at the /dev directory, and basically this is the device files, like for example hardware, keyboard, monitor, anything that's externally connected to your Linux server or your Linux operating system is managed in the /dev directory. Then we're going to look at the proc and the sys directory, and there's another directory that we're going to look at which I didn't put here, is the the /boot directory. If you go to our Linux file system right here, we're going to see that there's a directory known as the boot directory. So we're also going to talk about this directory to have a better understanding of what this directory does. So guys, these are the directory we're going to look at. We're going to look at the bin, we're going to look at etc, we're going to look at the sbin, then we're going to look at the home directory, and we're going to look at the proc, the temp, the usr, we're going to look at root, right? Then we're going to look at boot, and we're going to look at the dev direct. So guys, that is what the Linux file system is. The Linux file system is simply a way or a method used by Linux to organize and store files on the Linux operating system. And the Linux file system starts with the root directory, and any other thing comes under that root directory. directory. So if you delete the root directory, you have technically deleted your entire Linux file system. And the most used Linux file system is the ext4, which stands for the fourth extended file system, and is the most used file system. Why? Because it is stable, it performs better, and it is scalable as well, right? And it's way better than the previous file system, that is the ext2 and the ext3. So guys, that is what the Linux file system is. In our next video, we are going to look at the commands that are necessary to navigate the Linux file system. See you in my next video. Bye. Hello guys, what's up? Welcome back to the channel. Yes, again, Emmanuel Gijon, and in today's video we're going to learn some basic Linux commands that you will need to navigate the Linux file system. So I'm going to explain what a Linux command is, and I'm going to show you some basic commands that you can use to navigate the Linux file system, and I'm going to show you guys how these commands work. Before I dive into this video, I want you guys to do a couple of things for me. Please take some time to like this video. I've noticed that a lot of people are watching my videos, but they are not liking it. So please, if you enjoyed this video, or if you feel like you want to support me and encourage me to keep making videos, please hit that like button. So without taking much of your time, let's get started. So right here on the left side of my screen, I have what they call a command line interface. In my previous video, I explained what a command line interface is. As you can see, this is what they call a shell prompt. And I said, whenever you see a shell prompt, know that your Linux operating system is ready to accept commands. Now, on the right side of my screen, I have a graphical user interface, right? And I also explained what a graphical user interface is. If you're logged into your server, you may not see this graphical user interface. You may always see a command line interface. That's fine. Don't panic. The reason why I'm seeing a graphical user interface and a command line interface at the same time is because I'm running Ubuntu desktop. I can show you guys how to install Ubuntu desktop on your servers, but I intentionally did not make that video. Why? Because I want you to be comfortable with the command line first, right? All your life, you've been using a graphical user interface. If you have a MacBook or a Windows computer, you've been using a graphical user interface. So I want you to be comfortable with a command line interface. So the reason I have this too is because I want you to have a visual understanding of what I'm talking about, right? Right here, we have what is known as a graphical user interface. As you can see, we are currently inside of the home directory. I said a directory is simply a folder. So right here, we are inside of the home directory or the home folder. Inside of that home folder, we have some folders. For example, desktop, documents, downloads, music, pictures, public, templates, videos, and a file and another folder, right? This is what you will see on a graphical user interface. Now, on a command line interface, you can see the same thing using a command. But before I go in and I start typing commands, let's first of all understand what a command is. A Linux command is a program or a script that you can run in the Linux terminal or shell to perform a specific task. So what we're seeing right here is the Linux terminal. Another way to define a Linux command is you can say a Linux command is simply a set of instructions that's text-based, which you give to your Linux operating system, and your Linux operating system will execute that command. So before we even start, right here on my left, if I click right here where it says home, you're going to see that it's going to give me the path where I'm currently present, right? So it's going to say I'm currently present in /home/Gijon. So the folder I'm currently in is a folder known as Gjon, right? And inside of Gjon, you have all of this right here. You can run a command in Linux that will also give you the path where you're currently present. It's known as the current working directory. And I said in my last video that this right here represents the current working directory. And this sign right here represents the user home directory. I said there is a command that you can run and it's going to tell you exactly which user you're using. And I also said that you don't even need to run a command. If you look at it right here, you'll see that I'm currently logged in as Gjon and I'm a regular user. So when we look at this, it says we are in /home/Gjon, right? Gjon is the user, and these are all the folders that are under Gjon. If you want to see the same thing on a command line interface, we're going to need to run a command, and that command is called pwd. And pwd stands for present working directory. Some people refer to it as print working directory. Some people refer to it as present working directory, but the right answer is present working directory. And if I hit enter, as you can see, it says, hey, you're inside of /home/Gjon. Same thing that is right here. So, but why am I not seeing these folders, right? Why am I not seeing desktop, documents, downloads, music, pictures, public, template, videos? Why am I not seeing it here? The reason why I'm not seeing it is because I've not yet instructed my Linux operating system with a command to show me everything that's inside of this directory. So if you want to see everything that's inside of your directory, you would have to use a specific command, right? And that command is ls, and ls stands for list, right? So if I hit enter, it's going to list all the files and directories that are under my current working directory, or that are under my present working directory. So as you can see, the command ls will simply show you everything that's under your current directory. And how do you know your current directory? You type pwd, and if you type present working directory, it would give you your current directory. Now if I go right here on the graphical user interface, I can go inside of this directory called desktop by clicking on it. Right now, as you can see, I'm inside of desktop. How do I know? If I come up here, you'll see it says I'm inside of /home/Gjon/desktop, right? Now in Linux, I can do same. I can go inside of desktop, right? In order for me to go inside of desktop, I will have to use a command, and that command is known as cd. cd means change directory, or change the current directory. So presently I'm in this current directory, and these are all the directories that are listed or that live under this directory. And now I want to change my directory and go inside of this directory called desktop. So I'll have to use the command change directory space. Then I'll have to specify the name of the directory I want to go into. In this case, it's going to be desktop. So if I hit desktop and I hit enter, now I'm inside of desktop. How do I know? You simply type the command pwd and you hit enter. It's going to tell you that, hey, right now you're inside of /home/Gjon/desktop. Same thing that we're seeing here. And if I want to see everything that's inside of desktop, I'll have to use the ls command. Ls means list. So I'll have to use the ls command. I'll hit enter and nothing shows up. Why? Because if you look at on the graphical user interface, you see that this folder is empty. So don't expect anything to show because there is nothing in there. Now, what if I want to go back, right? Now, on a graphical user interface, I can simply click right here and it will take me back to my home directory. Now, if I want to do the same thing in Linux, I will have to type a specific command, right? And that command would be cd, which is change the directory. Since I'm moving up one level of the file system, I would have to, specify dot dot. Dot dot means parent directory. So I want to change back to the parent directory. Now, let me explain this. All of these folders that you're seeing right here, all of these folders are inside of this folder. So this folder is their parent. So in order to see these folders, you will have to go inside of this folder right here. We went inside of this folder, and while we were inside of this folder, we went inside of this specific folder. Now we want to go back to this folder right here. So that's why we use this command called cd dot dot. This dot dot means parent directory, and the parent directory of desktop is what is Gjon. Why? Because desktop lives inside of Gjon. So if I hit enter, you see it's going to take us back, right? And if I do pwd, you see right now I'm inside of /home/Gjon, and if I do ls, right, it's going to show me everything that's inside of Gjon, right? And I can go again to another specific folder. For example, I want to go to documents, right? Simply click, it takes me inside of documents. As you can see, it's empty. If I want to do it on the command line interface, what do? Cd, and I specify the name of the directory, in this case, documents, right? And I hit enter. How do I see everything that's under documents? I simply do what? ls, and I hit enter. There is nothing. Why? Because there is nothing inside of this folder, right? There is nothing inside of that directory. What if I want to go back? I simply do cd dot dot and I hit enter, and it takes me back to that directory. How do I know? If I do pwd and I hit enter, you see I'm in /home/Gjon. Now on a graphical user interface, I simply click here and it takes me back to the home directory. Now the next command I want you to know is the clear command, right? At times you may run out of space on your terminal. As you can see, I'm already running out of space, so I need some space. So I need to clear everything, right? If you want to clear everything, you simply type the clear command. It's like this, clear, and you will hit enter, and basically it will clear everything and it will give you some space to work with. Now let me do ls one more time. As you can see, we do have a couple of directories once again. The next thing we're going to learn, or the next command we're going to learn, will be the command to create directories. On a graphical user interface, if I want to create a directory, I simply right click. It will give me an option to create a new folder. In Linux, there is a command that you can use, and that is the make directory command, right? So make directory, and you will specify the name of the directory you want to create. So let's say I want to create a directory called applications, right? And I'll hit enter. Now on the right side, you will see that a new folder has been created called applications. Now if I want to see it on a command line interface, I'll simply do, and I'll hit enter, and you'll see right here that a new folder was created, or a new directory was created, right? How do we create directories? You do a make directory and you specify the name of the directory, in this case infrastructure, and you hit enter. on the right side, you'll see a new directory was created right here, infrastructure. And if you want to see it right here, you have to use the command ls, right? So if I do ls, I'm going to see that I now have a new directory called infrastructure. I can create another directory. I'll use the command make directory and I'll call this security, right? And I will hit enter. All right, maybe I want to create another directory for scripts, right? And I'll do a make directory and I'll say scripts, right? Or I'll say script and I'll hit enter. Now, if I do ls, you'll see that I now have a directory I just created called applications. I have a directory called security. I have one called infrastructure and I have one called script. So let's say I created these directories and my manager comes to me and says, hey, Emmanuel, we noticed that you created a directory called script. We want it to be scripts with an S, right? So I have to rename it. So if you want to rename a directory in Linux, you would have to use a specific command. And that command is what they call the move command. So I'll have to do move script and I'll specify the new name. I want to move it to script now with an S, then I'll hit enter. So now if I do ls, this one right here without an S was changed to this one with an S. So that's how you rename, directories, right? For example, let's say I want to rename this to software downloads, right? I don't want it to be downloads. I just want it to be software downloads. I would do move download. I'll do move download and I'll specify the new name. And the new name would be software underscore download. Now, don't worry about why I'm putting an underscore here. When we start navigating the file system, there are three important things that I'm going to tell you about the file system. So I'll do a move download, then I'll do soft underscore download, then I'll hit enter. Now, if I do, you will notice that download right here or download has changed to soft download. Now let's say my manager comes and says, hey Emmanuel, it has to be soft downloads with an S. So what do? We do a move, we specify soft underscore download and we specify soft underscore, maybe they want it to be capital letter as well, download with an S, then we hit enter. The original file name does not have an S, so I'll take out the X, I'll take out the S and I'll hit enter. Then now if I do ls, you notice that it has changed from a soft download without an S and without a capital letter to a soft download with an S and with a capital letter. Now let's say I want to rename it back, right? I'll simply do move, right? You do move soft underscore download to what? Downloads, right? And I'll hit enter. Now if I do ls, you notice that it's back to its original form. So that is how you can create a directory in Linux using the make directory command, right? So now let me clear my entire screen and now let me do ls. Now let's say we want to go into applications, so I can do a cd into applications, right? And I will hit enter. And inside of application, I will do ls. As you can see, there is nothing inside of application. And if I click on application on the graphical user interface, you also notice that the folder is empty, right? We just created it. There's nothing in there. Now, another thing you have to know is that you can also create a directory inside of a directory. For example, here I can do a make directory and I can call this directory src, right? Source code, and I will hit enter. As you can see, a new folder was created. Now if I do ls, you can see we now have a new folder in here, and still in here I can create another folder called make directory, and I'll name this, configuration. So basically name this config, right? So do config. I will hit enter. So if I do ls, I'll notice that now we have 2 directories. Now let's say all the directories have to be small letters, right? So I have to rename these. I'll simply do a move src with a capital letter, src with a capital letter to src with a small letter. So now if I do ls, you see everything is small letters. So now I have 2 directories. Now if I want to know where I am, I can do and it says I'm inside of /home/gjon/applications. Now if I want to move one level inside of the file system, I can simply do a cd ... This dot means parent directory. Change to the parent directory, and I hit enter, and I do see it takes me back here. And if I do ls, it's going to list every single directory that's under this specific directory. On the graphical user interface, all I have to do is to hit this backward key, and it's going to take me right here. Now, inside of this directory, I can also go to another directory. For example, I can go to infrastructure. I can cd inside of infrastructure, and I will hit enter. Now, if I do a pwd, you'll see that I'm inside of infrastructure. On the graphical user interface, I can basically just click inside of infrastructure, and it takes me right here. As you can see, for now it's empty. And right here, I can create, different folders, right? I can create a directory for dev, for example. So I can do a make directory, and I can name this directory dev, and I can do another make directory, and I can name this directory des, right? And I can do another make directory, and I can name this directory, prod, and I will hit enter, right? So as you can see, now we have 3 directories under this specific, directory. Remember that you can always clear your screen if you want to. So guys, that was how to, create directories. So the next thing we're going to see is how to create a file. So let's go back, right? Let's go back to our home directory. Right here, we're back in our home directory. So I'm going to do a cd ... Hit enter. If I do ls, I'm back in my home directory. So the next thing we're going to do is to see how to create a file in Linux. There are 3 ways you can create a file in Linux, right? So the 3 separate commands you can use to create a file in Linux. So the first one is you can use the tosh command. So if I say tosh, the tosh command is the command that you can use to create a file in Linux. So I can say tosh, and I will say tosh sample underscore file 1.txt. So you will say tosh, and you will specify the name of the file you want to create. So if I hit enter, if I come back here on this graphical user interface, you see that we now have one file here called sample underscore file 1.txt. So if I do ls right here, you see I now have one file right here. Now there's something very, very important I want you to remember. Linux does not use extension to recognize files. So for example, if I do a tosh and I simply call this my underscore file, right? And I hit enter and I do ls, you're going to see that I have a new file right here called my file, right? My underscore, file, right? So the tosh command is a command that you can use to create files in Linux, right? Another way you can create files in Linux is by using a text editor. There are a couple of text editors you can use. You can use VI, you can use Nano, or you can use Vim, right? So you can use VI, you can use Nano, or you can use Vim. In this specific example, I'm going to use Nano, right? So all you have to do is you have to say Nano, and you specify the name of the file you want to create. So I want to create a file called sample underscore file2.text, and I will hit enter. So with the text editor, it does not just create a file, but it gives you the option to input some text inside of that file. So I'm just going to put some random text inside of this file. This is the random text that I'm going to, put inside of this file. Hi, my name is Emmanuel and I love Linux. Then I'm going to do a Control O, I'm going to hit enter, and I'm going to do a Control X. Now, you will notice that a second file has been created called sample underscore file2.text, right? Now, if I clear my screen and I do LX, you're going to see that now I do have another file called sample underscore file.text right here. And I can see what's inside of this sample file too without going inside of it. And I can use a Linux command known as cat. Basically, what cat does is that it displays the content of a file. So if I do cat and I specify the file I want to see the content, I will do sample underscore file2.text, and I will hit enter, and it will basically display what's inside of that file, right? As you can see, hi, my name is Emmanuel and I love Linux. So that's another way you can create a file in Linux by using a text editor like Nano, VIO, Vim. Now, the third way you can create a file in Linux is by using the copy command. In order to use the copy command, you will need a file that already exists, right? And in this case, we're going to use this file right here. I'm going to use this file to create another file. Basically, I'm going to copy this file and use everything inside of this file to create another file. And the way it works is you will use the command copy. So you will say copy, which is CP. You will give space. Then you will give the file you want to use, right? The file you want to copy from, which is, sample underscore file2.text. And you specify the name of the new file you want to create. In this case, I want to create a file called sample underscore copy.txt, and I'll hit enter. As you can see, another file was created, right? So if I do LX, you'll notice that we now have another file here called sample underscore copy.text. Sample underscore copy.text was created from sample underscore file2.text. It means whatsoever is inside of this file is the same content that's inside of this file. And how can I see the content of this file? Guess what? I use the cat command. So I can say cat sample underscore copy, right? That's the new one we created, .text, and I'll hit enter. As you can see, it says, hi, my name is Emmanuel and I love Linux. And it's the same content that's inside of sample underscore file2.text. So if I do cat sample underscore file2.text and I hit enter, you say, hi, my name is Emmanuel and I love Linux, right? And you also notice that sample underscore copy.text also has, hi, my name is Emmanuel and I love Linux. Why? Because this file is a copy of this file right here. So those are the three ways you can create files in Linux. So let's do something fun, right? Let's do an LX. Let's go inside of this directory called applications. So I'm going to do a cd into applications. I will hit enter. So I will do LX. As you can see in here, we have what? We have two directories. So if I do pwd, I'm right here. If I do LX, is this what is in here? And I can do a cd into rc and I hit enter. If I do pwd, you'll see that I'm inside of /home/gjon/apply application slash src. And in here, I can create a couple of files, tosh, and I can create a file called app.py. I will hit enter. If I do ls, you now see that right here, we have a file, right? And I can also create another file by doing tosh. The name of the file called is utility, utility.py, and I'll hit enter. Now if I do ls, you see now inside of this directory, we have 2 files, right? And I can clear my entire screen and I can do a cd dot dot. If I do pwd, we're back inside of applications. If I do ls, this is everything that's inside of applications, right? And I can also go inside of config and I create some files. So I can do cd inside of config and I do ls, there's nothing. And here I can create a file and I can do, tosh, and I can specify, the file as, config.yml. Don't worry about what all of these extensions are. And I'll hit enter. Now if I do ls, you'll notice that there is, a file right here that has been created. Now, let's go back to our, user home directory. For example, if I do pwd and I hit enter, you're going to notice that I'm inside of /home/gjon/application/config, but I want to go back to /home/gjon right here, which is my user home directory. Now, I can do a couple of things. I can do cd dot dot and it will take me back here. Then I can do another cd dot dot and it will take me back here, but that's a lot of work, right? Now, if I want to go to my home directory, I can simply specify my home directory and I go, straight to my home directory, right? My home directory is right here. So I can do a cd to my home directory. So I'll specify my, my home directory. Remember I said this right here represents the user home directory and I'll hit enter. Now, if I do pwd, you see I'm back in my home directory. I didn't have to go through the, cd dot dot, cd dot dot. I'm straight back into my home directory. So let me clear my screen. Let me do an ls. And now let's say we want to delete, these files right here, right? So if you want to delete a file in Linux, there is a command to delete a file, and that's the remove command. But before I talk about the remove command, let's say I want to rename this file right here. I want to rename these 2 files. I want to rename this my file, this my underscore file, and I want to rename this sample file. Remember the command we used to rename directories? You can also use that same command to rename files, right? So I will do a move my underscore file and I will rename it to my underscore file dot txt and I'll hit enter. Now if I do ls, see it was renamed. And I want to rename sample and I will simply do a move sample to sample.txt and I'll hit enter. Now if I do ls, you'll notice that it has been renamed, right? So that is the use of the move command. Now let's say I want to delete these files, right? So there is a command to delete files in Linux and it's called the remove command. So remove like this. So I'll do rm space and I'll specify the name of the file I want to delete, right? So I'm going to start with this file right here. So that is my, underscore file.txt and I'll hit enter. Now if I do ls, you notice that that file is gone. That file has been deleted. Now let's delete these other files right here. So I'm going to do remove and I'm going to do sample.txt. I'm going to hit enter. If I clear my screen and if I do ls, you notice that that file is gone, right? So I can do remove and I can specify multiple, files, right? For example, I want to remove sample, underscore file 1, or let's say file 2. And I also want to remove sample underscore file, 1. And I want to remove this one as well, the copy one. And I want to remove sample underscore copy.txt, right? If I hit enter, then if I do ls, notice that all those files are gone, right? All those files are gone. So that's kind of how you remove files. Remember that we've created some directories, right? Let's see how to delete directories. For example, let's say we want to delete this directory called security. We want to delete this directory called script. And we want to delete this directory called infrastructure, and we also want to delete this directory called applications. Now, in order to delete directories, you have to also use the remove command. So I'm going to say remove, and I'm going to specify the name of the directory I want to delete. In this case, I want to delete this directory called security, right? And I'm going to hit enter. See, it says cannot remove security, and it says it's a directory. So basically, it's telling me that this command cannot remove this because this is a directory. So what's happening? When we try to use this command to delete files, it worked. So why are we trying to use it to delete directories? It's not working. So what's happening, right? What's wrong? What's happening with this, command? Now, if you find yourself in this situation, this is where a command known as the man command comes in. The man command is a very important command. So basically what the man command does is that it gives you an explanation of different commands and what these different commands can do, right? So if you find yourself in this situation where you cannot delete, where a command is not working when you know it's supposed to work, the first thing you have to know is that it means you have to pass an option. So you have to say, hey, I want to delete a directory, right? Because remember, when we used rm, it deleted a file. Now we're trying to use it to delete a directory. It's not going. It says cannot remove securities because security is a directory. So it means we have to pass an option in order for Linux to know that we are not trying to delete a file. Instead, we are trying to delete a directory. Now, we don't know the option to use. So if you don't know the option to use, this is where, as I said earlier, the man command comes in. So basically, the man command gives you details about a command. For example, I can say man, and I'll specify the command I want to know more about. In this case, I want to know about the man command, right? So I'll do man, and I will hit enter. So it takes me to what is known as a manual page. So it's going to give me the name of the command. The name is man, and it says the man command is an interface to the system's reference manual. So basically, it's a command that would give you information about other commands. So let's go back to our command prompt. So we are back in our command prompt, and we've noticed that the remove command is not working. So let's see if the man command can give us more information about that command and can even go as far as giving us the exact option we can use to delete these, directories. So I'll do man, and I'll specify the command I want to know more about, which is rm, and I will hit enter. So it says here that the name of the command is rm, and this command is used to remove files or directories. So we just try to use it to remove a directory, but it's not working. But when we look at the manual, it says that it's used to remove files and directories. Now we can read more about the man command, or we can go right here where it says options. Basically, you can specify an option, right? And in our case, we will have to specify the option that we want to delete a directory and not a file. So let's find that option. So right here, you can see some options. You can see, for example, false. You can see -i. Then we're just going to go right here to where it says -d or -dir. It says remove empty directories. So this is the command, or this is the option we are looking for. So let's try that option. So I'll take back my command prompt, and I'll say I want to remove. Then I'll pass that option -D. Then I'll specify the name of the directory I want to remove. In this case is security, and I will hit enter. Boom, that directory is gone. If I do, the security directory is gone. Now let's say we want to remove infrastructure. Now if I do ls, I will see infrastructure right here. So I can do remove -D infrastructure, then I'll hit enter. It says here that infrastructure cannot be removed. Why? Because the directory is not empty. We're going to come back to this. Let's remove another empty directory that we created. Let's remove this script directory. So I'm going to do remove -D, and I'm going to do script. Then I'm going to hit enter. If I do ls, you see that script directory is gone. Now let me clear my screen and let me do an ls. Now let's try to remove infrastructure one more time. So if I do remove -D infrastructure and I hit enter, you see it cannot remove infrastructure. It says the directory not empty. It means there is something inside of this directory. Now remember that when we used the man command and we did a man rm, we went into the man command. When we were looking around, we noticed that this option we use says it removes empty directories, meaning that if a directory contains anything, it will not remove that directory because that directory has something in it. Now there is a command we can use to see exactly what's inside of that directory. Now we can cd inside of that directory and do an ls to see what's inside of the directory, or we can just stay right here and run a command to see what's inside of this directory. So this command is list. We already know the list command. So for example, so if I do list, it's going to list everything that's in this directory, but I don't want it to list things that are inside of this directory right here. I don't want it to list everything, right? So let me clear my screen. Let me do an ls. We want to see all of what's inside of this directory. So you will do ls, you will do a space, then you will specify the path of that directory. Now, if you don't know what a path is, this is what I'll advise you to do. Just do ls dash specify the path of the directory. So you copy this. So the path would be /home/gjon, right? Then you specify the directory that you want to see the content that's in it, which is this directory right here. Then you would hit enter. So basically, it's going to show us what's inside of that directory, right? So it's going to say, hey, inside of this directory, you have the dev folder, you have prod, and you have, test, right? So this is what is inside of this directory. Now that you know what's inside of this directory, you can choose to delete this directory or not. In our specific scenario, we choose to delete this directory. We're trying to delete this directory using the remove command -D is not working because the -D option only removes an empty directory, and this directory right here is not empty. And we don't have time to go inside of this directory and start deleting these folders. It's going to take us a lot of time. So what we want to do is we want to look for an option that will allow us to delete directories that are not empty, meaning that even if they have content in it, we still want to delete it. In this scenario, we don't know what the option is. Guess what? We can use the man command. So I'm going to do a man rm and I'm going to hit enter, and it's going to take me right here. Now let's look at the options, right? Let's quickly look at the options to see. I see an option here and is the recursive. It says remove directories and their content recursively, right? That is the option that we want. So I'm going to gain back my terminal and I'm going to say remove -r recursive delete. and I'm going to specify the directory, and I'm going to hit enter. If I do ls, boom, that directory is gone. Let's remove this other directory that we created called application. So if I do an rm, I do a -t, and I do application, and I hit enter, it's not going to work. It's going to say, hey, listen, this directory is not empty, and because this directory is not empty, we cannot delete it. Now, if you want to see everything that's inside of this directory, you can basically just use this command ls, you specify the path, and you would simply do, applications, and you hit enter, and it's going to tell you that inside here we have, config src. So if we want to delete it, we simply do a remove dash r recursive delete, and we specify the name of the directory, and we hit enter. If we do ls, you see, now that directory is gone. So that's how important, you see, the man command is. The man command can help you in Linux do a lot of things. For example, let's say I want to know different options I can use with ls. I will do man ls, and I will hit enter, and you see right here, the first option I see is the -a. It says, do not ignore entries starting with dot. When you see a file that starts with dot, it means that's a hidden file. So if you want to see hidden files in Linux, you will do an ls-a, and you will hit enter. Now you see there are more files, right? When I do a simple ls, these are all the files that I see. But when I do an ls-a stands for all. Now you can start seeing some hidden files like this one right here. These are hidden files, and you can see some hidden directories right here, and you can see more hidden files right here. So this is an option, that you can use, the -a. And another thing also is that you can also create a hidden file, right? For example, I can do a tosh, and I can do dot. All hidden files starts with, the dot, and I will simply say my underscore hidden underscore file, and I'll hit enter. Now if I do ls, you will not see that file. It's not there. So where is that file? It's a hidden file. So how do you see hidden files? You have to list everything. So you have to do a -a, and you have to hit enter. Now if you look carefully, you're going to see that file right here, and you can remove it, right? So I can do an rm, then I can do a dot, and I can specify the name of the file, my hidden file, then I can hit enter. Now, if I do an ls, I won't see the hidden files, but if I do an ls-a, boom, you see, that hidden file is gone. I've deleted, that my underscore hidden file, and I can even delete this other hidden file right here. So I can do a remove, dash, hidden file, and I'll hit enter right here. Then I'll clear my screen, and I'll do ls, and I can do ls-a. Now I can also do man ls. Then I can see more options that that I can use, right? For example, it says -f, list all entries in directory orders, right? Let's just keep going. As you can see, there are a lot of options that you can pass, right? It says -l, use a long listing format. So let me get back my terminal. So let me clear my screen. When you do ls, this is how it's going to list everything that's inside of that directory. But if you do an ls-l, it's going to use a long listing format like this, right? Yeah, that's what it means. And it's also going to give you more information about, the file permissions or the directory permissions. Don't worry about what permissions are. We're going to talk about it. Another important command you can use, or another important command you're going to use when we're navigating the file system, is a command called history. And basically what the history command is going to do is that it's going to display all the previous commands that you have executed on your terminal. So if I do history and I hit enter, you see it will show me all the commands that I've executed on my terminal, right? So I've used ls, I've used cd to desktop, I've used tosh, I've used man, I've used clear, I've used man ls. So it will basically just show you all the commands that you've used, on your terminal. If you're looking for a specific command that you just used, you can use the up arrow key on your keyboard. So basically you just do up arrow key and it's going to show you, all the commands that you've used on your machine. As you can see, it's showing me cd desktop, lx, clear, find, clear, man, lx, it's going to show you all the commands that, that you've used on your machine. That's a very, useful trick that you can use when you're navigating the Linux file system. So guys, those were the commands that you will need in order to navigate the Linux file system. So in our next video, we're going to... Hello guys, what's up? Yes, I'm Manuel Gijon, and in today's video, we're going to navigate the Linux file system. Before I get started, please, if you have not yet subscribed to this YouTube channel, please take 1 second to subscribe and also smash that like button to encourage me. So let's get started. So in my last 2 videos, my focus was on the Linux file system. I made a video where I explained what the Linux file system is, and in that video, I said the Linux file system was a method used by Linux to organize and store files on the Linux operating system. So it's just a method to store files on the Linux operating system. And I also said that the file system starts from the root directory, and the root is represented by this sign right here, which is a slash. And I did not just stop there. I also said that, the most used type of Linux file system is the ext4. And I said ext4 stands for the root extended file system. And I said it's the most used type of file system in the market because it's stable, it's reliable, and it's scalable. One thing I did not mention in my previous videos was that you can run a command on your terminal and it will give you the type of Linux file system that you're using, and that command is the disk3-type. So if I run this command, I will see the type of file system that I'm using. So back here in my terminal, I'll run the command df-T and I will hit enter. This command will give you some information, but most importantly, it will tell you the type of file system that you're using. As you can see right now, I'm using the ext4. Another command you can run is the cat/etc/file system table and you hit enter. This command will also give you some information on the type of Linux file system that you're using. As you can see right here, I'm using the ext4 file system. Here are some important things that I want you to remember. The first thing I want you to remember is that the file system starts from the root directory. And the second thing I want you to remember is that the root directory right here is represented by this sign right here. And I also said if you run the command cd/, it will take you to the file system. There is something that's very, very important that I want you to remember. In Linux, everything in Linux is a file. Users are files, commands are files, network settings are files, security are files, devices that are connected to your Linux servers, they are also files. So back here in our terminal, we're going to access our file system. There are a couple of things I want you to notice. The first thing is that I want you to see that I'm currently logged into this server as Ubuntu, and Ubuntu is a regular user. And I say whenever you see the $sign, know that the user you're using is a regular user. And another thing that you're going to notice is that we are currently inside of the user home directory of Ubuntu. And if I run this command pwd and I hit enter, it says we're inside of /home/Ubuntu. So we are not inside of the root directory. So if we want to go into the root directory, we'll use the command cd/ and we hit enter. If I do pwd and I hit enter, you will notice that we are inside of the root directory. And right here in the root directory, I can run the command lx and it would list all the directories that are inside of the root directory. As you can see, there are a lot of directories inside of the root directory. As a beginner, you must not know all of these directories and the use of all of these directories. In this video, we're going to pick a few of these directories, which I think it's important for you if you want to become a DevOps engineer to know, and we're going to explore them to have a better understanding of what they do. So the first directory we're going to look at is the /home directory. The /home directory is a directory for each user on the Linux operating system, meaning that each user that's on your Linux operating system, you can find them in here. And let me explain all of this. In Linux, you have the home directory. So this is the home directory right here. Now, let's say you have a user, like for example, we just saw I was logged into this server as Ubuntu. Ubuntu will have its own directory inside of the home directory. Now, let's say you create another user, for example, John. John will have its own directory inside of the home directory. Now, these directories is what they call the user home directory. And the user home directory of Ubuntu is what contains files, configuration, and data that belongs to Ubuntu. Now, another thing that's very, very important for you to know is that the content, any piece of content that's created under the, I'm going to, refer to this as Ubuntu, and I'm going to refer to this directory here as John. Another thing you have to know is that anything that Ubuntu is doing inside of its user home directory cannot be accessed by John, and anything that John is doing inside of its own user home directory cannot be accessed by Ubuntu. So let's access the home directory and let's see what we can find in there. So back here in my terminal, to access the home directory, I'll do a cd home and I'll hit enter. Then if I do pwd, see I'm inside of /home. Then if I do ls, you'll notice that right now there's only one user home directory that's inside of the home directory, and that's the directory of Ubuntu. I can go inside of this directory called Ubuntu and I'll hit enter. Now you'll notice that right now I'm inside of the user home directory of Ubuntu. This sign is indicating that I'm inside of the user home directory of Ubuntu. So if we create another user called John, for example, John will have its own folder here, and if we create another user called Mary or Paul or Peter, they will all have their folders here. So that's the use of the home directory. The second directory I want us to talk about is the root directory. But before we talk about the root directory, I want to explain something to you. In Linux, we have two types of users. We have regular users and we have administrator. An administrator in Linux is called root, and root is the most powerful user in Linux. And root has full access to the Linux operating system, something that a regular user like Ubuntu does not have. There are things that Ubuntu cannot do on a Linux operating system, or any other regular user cannot do on a Linux operating system, but root can do it. Now, because root has full powers to your Linux operating system, root can do things like modify files, change system settings, manage users, including creating users and even deleting users. So if root feels like a specific user is not supposed to be on a Linux system, root has the powers to delete that user. Now, another important thing you have to know is that the /root directory is the user home directory of the root user, just as the /home is the user home directory of Ubuntu and other regular users. The root directory is the user home directory of the root user. Another important thing you have to know is that regular users cannot access this directory unless they use the sudo permission. They are not allowed to go inside of this directory. So let's go explore, the root directory. So back here in my terminal, I will do a cd to root and I will hit enter. The first thing you notice is that I don't have the permission to go inside of this directory. Why? Because I'm currently logged into this server as Ubuntu, and Ubuntu is a regular user. So if you want to go inside of this directory, just type sudo -i. Sudo here means super user do, and the -i means interactive share. Then if I hit enter, boom, now I'm inside of the root directory. And if I do a pwd, you see I'm inside of /root. I want you to pay attention to a couple of things. The first thing I want you to pay attention to is that I'm no more Ubuntu, but I'm now root. So in order for me to access this, I was forced to use the root user. And the second thing you have to notice is that the prompt sign has changed into a pound sign. And I said, whenever you see a pound sign, know that you're currently logged into that server as an administrator. The third thing I want you to notice is that I'm inside of the user home directory of root. So that's the use of the root, directory. Another directory I want to talk about is the bin directory. First thing I want you to know about the bin directory is that the bin stands for binary, right? The bin directory contains important executable programs and commands needed by the system. And also you have to know that the /bin contains binaries of all all users and commands like ls, cp, move, run, and cat. So all the commands you run on your Linux operating system are inside of this /bin directory. Apart from having the /bin directory, there's also another directory known as the sbin directory. And this sbin stands for system. So this S in front of the bin stands for system binaries. This directory holds binaries that only system administrators can use. Like for example, to create a group, or to create, for example, a user, to assign permissions, to take permissions, to delete things are inside of this binary, right? Now, to explain it like this, Ubuntu would use the bin directory to execute its command, but root would use the sbin directory. That's kind of the difference between the two. Let's go and try to explore these directories. So back here in my terminal, I'll do a cd into bin and I'll hit enter. Then if I do ls, you're going to see some files in here. Here is ls, and inside of this file there is the code or the binary or the executable that makes it possible for the ls command to work. Let's see what's inside of this file. So to see what's inside of that file, I will do a cat ls and I'll hit enter. So this is what is inside of that file. I don't understand none of this, and I don't expect you to understand it as well. Most people, they don't understand it. Even people that have been doing Linux for years, they don't understand what's this. So what we're going to do is we're going to take back our terminal, and I want to show you something. So if I do a find dash name and I specify the name of the file, for example, let me say ls, you're going to see that there's a file right here called ls. Now, if I delete this file, the ls command is not going to work. Let's try it. But before I delete this file, let's back it up. So what we're going to do is we're going to copy this file and we're going to create a new file called show. So I'm going to do copy ls to show. I'm going to hit enter. It says I don't have permissions. That's fine. So I'm going to do a sudo copy ls to show. And I'm going to hit enter. Now, if I do a find dash name and I specify show, you're going to see that there's a new file on our system called show. So let's delete the ls file. So I'm going to do a remove ls. I'm going to say yes, I want to remove ls. I'm going to say yes. You see, I still don't have the permissions to remove ls. So I'm going to do a sudo remove ls. And if I do a find dash name ls, you see that file is gone. So if I do ls, it's not going to work. Why? Because the file that contains the binary that makes it possible, or the executable that makes it possible for the ls command to work, is gone. But if I do show, you see, show works just as ls. Why? Let me explain. So we have a file called ls, and inside of this file called ls, there is the binary, the code, or the executable that makes it possible for the ls command to work. So what we've done is we've copied that binary over to a new file called show, and we've deleted this file. So whenever we run ls, the system tries to look for the ls file and tries to look for all those binaries and those executables and stuff like that, and it cannot find it. Why? Because we've deleted it. But when we run the command show, the system can access that file and be like, okay, these are the binaries, or these are the executable, and this is what this command is supposed to do. I don't know if that makes sense. Does it make sense? I don't know. Leave in a comment below if that makes sense. If I want to put it back, I'll just do a sudo copy show and I will do ls and I'll hit enter. Then now if I do ls, see, ls is going to work, right? So this is what the bin directory does. Now let's look at the sbin directory. So if I do an ls and I cd into sbin and I hit enter, if I do ls, you're going to see binary executables that only an administrator can use. Let me show you. For example, the ability to add a group, or an administrator can do it. The ability to add a user, only administrators can do it. So inside of this specific directory, you're only going to see commands that only administrators can execute them. The next directory I want us to talk about is the etc directory, or the etc directory, right? I just love calling it the etc directory. And this directory contains system configuration files and settings. That is, the files in this directory are used to configure the system, services, and applications. So anything that has to do with configuration on your Linux operating system is found inside of the etc directory. And in this directory, you're going to have files like the etc/password that contains user account information. You're also going to have the etc/file system table. You're also going to have the etc/host that maps host names to IP addresses, and you're also going to have etc/network. Basically, it's a directory that contains all the network configurations of your Linux operating system. And finally, you can also find the etc/SSH. Basically, it holds the configurations of the SSH service on your server. So let's go into this directory and let's explore this directory. So back in my Linux terminal, I'll do a cd into etc and I'll hit enter. Then if I do ls, you see all of these files here are different configurations, right? And one thing you're going to notice is that all of them will end with this extension of .config, right? And here, as I said, you're going to have directories like this. So if I do, for example, cat, and I say cat pass wd and I hit enter, see, you're going to have information about different users on this server. For example, you're going to see right now we have root and we have, Ubuntu, right? Let me just clear my screen. And as I said, also in here, you can have information about the type of file system you're using by looking at the file system table. So if I do cat etc, if I do cat file system table and I hit enter, it's also going to give me, some information. And most importantly, it's going to say, hey, you are using the ext4 file system. So that's the use of this directory. All your configuration, all your system configuration are inside of this directory. The next directory I want us to talk about is the /boot directory. This directory contains files needed for your system to boot or for your system to start. This is not a directory you mess up with. So when you shut down a server and you restart that server, this is the directory. This directory contains the files that the system uses to start your server. So it's not a directory you mess up with. And also something that's very, very important about this directory is that the kernel information is inside of this directory. If you don't know what the kernel is, I made a previous video where I talked about, this 7 best Linux distributions you can test in 2025. And in that video, I defined what a kernel is. So the kernel information is also found in this directory. And there's also something that's extremely important. Without this directory, I'm sorry, your server will not start. So if you delete this directory, your server will not start. And a regular user cannot delete this directory, right? You must be an administrator in order to delete this directory. So let's go into this directory and let's try to see some files that are inside of this directory. But before we go, I want you to remember that inside of this directory, there's another subdirectory called crop. And basically this directory holds all the configurations for your system to start. So back in my terminal, I'll do a cd into boot and I'll hit enter. So these are all the files that your system needs to start. And this is also an extremely important directory. The crop directory basically contains configurations needed by your system to boot perfectly. So if we go into this directory, we can also see some files inside of this directory. So, this is not a directory you want to mess up with. My advice is you should never touch this directory. You should never delete this directory. You should never go near this directory unless you know what you're doing, unless, you're 100% confident and you know what you're doing. Because if you mess up with this directory, you have messed up with your entire server. Another important directory is the /dev directory, and dev here stands for devices. This directory contains information that makes it possible for you to interact with different hardwares that are connected to your computer or to your servers. Like for example, since our server is on AWS and it's a virtual machine, we are also going to have a virtual disk, and that virtual disk will be represented by the XVDA, right? So let's go into this directory and let's see if we can find this disk. So back in my terminal, I'll do a cd dev and I'll hit enter. Now if I do ls, you see there are a lot of files in here, right? And all of these are basically configurations of different devices that are connected to your server. And if you see carefully right here, you're going to see the file that's responsible for managing our virtual hard drive. This is not a directory you're going to mess around with a lot, unless you have something very, very specific you want to come here and do. This is not a directory you want to be playing with. So just leave this directory as it is and don't mess with it. Now, another directory we're going to talk about is the /lib directory. And basically, this directory is used to store shared libraries that are required for the system to function normally, right? That's the first thing I want you to know. Now, these libraries are needed by the /bin and the sbin directory in order to work. So if you delete this directory, the bin directory and the sbin directory will not work, because they need these libraries in order to function normally. And also want to note that we're also going to see another directory known as the lib64. I just want you to know that the lib64 contains libraries of the 64-bit program. I'm sure you're asking yourself, Emmanuel, what is a library, right? A library is a code that a program can use to perform a specific task. So this is not a directory you mess up with. This is not a directory you delete. So back here in my terminal, I'll do a cd into lib and I will hit enter and I'll do an ls. And right here you'll see a bunch of different libraries that your operating system would need in order to function normally. And you're also going to see, let me clear my screen, you're also going to see another directory here known as the lib64. So I'll do a cd lib64 and I will hit enter. Then if I do ls, then you're going to have just this right here. So let's leave this directory. Let me clear and let me do ls. Those are some important directories that I want you to know. Then the rest, I'm just going to not say it. Now, the temp directory basically is a directory where you keep temporal files. So if you have a file that's temporal, you can put that file inside of this directory. Then there's also the ops directory, and the ops directory is the directory where you go to find applications or software that you've installed on your Linux operating system that did not come with the Linux operating system. Then we also have the proc and the sys. They are like virtual file system. So I'm not going to spend too much time explaining all of these directories because there are a lot of them. As we proceed and we're learning more about Linux and learning more about other things, we're going to come back and use some of these directories that will help you understand them better. So thank you for watching this video. See you in my next video. Bye. Hello guys, what's up? Welcome back. Here's your boy Emmanuel, and in today's video we're going to see how to manage users in Linux. We're going to talk about things like who is a user in Linux, what are the different types of users you can find in Linux, and the role that each user plays in Linux. So this is an extremely important video if you're someone who's studying Linux, if you're studying to become a DevOps engineer, cybersecurity engineer, it doesn't matter. This is an important video. So first thing first, who is a user in Linux? In Linux, a user is an individual or a process that can access and interact with the Linux operating system based on the permission that they have. So it can be an individual. That individual can be a developer. That individual can be a DevOps engineer, or that individual can be a system engineer. And they will have the permissions to interact with your Linux operating system. Another thing you have to know is that in Linux, the different types of users. You have the root user, you have regular users, you have system users, and you have service users, or you usually call them service account. It's also important for you to know that some users in Linux will require a password in order to log in into the Linux system, while some users will not. You also have to know that each user in Linux has what they call a user ID. You commonly see it as UID, that stands for user ID, and this is the ID that's assigned to a user during creation. So if you create a user called Emmanuel, Emmanuel is assigned an ID, and IDs are very, very important because they can help you track and understand what a specific user is doing on your Linux operating system. When it comes to permissions in Linux, users have different permissions. They have different different permissions to access files, they have different permissions to access directories, and they have different permissions to access resources. For example, a developer may have the permission to read and edit a file, but will not have the permission to delete that file. But a DevOps engineer will have the permission to read, edit, and delete a file. So users in Linux all don't have the same permissions. Permissions are assigned to them based on their tasks and responsibilities. Another thing you have to know is that users are assigned a personal directory, and that directory is found inside of /home. Remember in my last video, I said if you access the file system and you go to /home, inside of /home, you will see personal directories of each user that's on your system. And I also said these directories are known as user home directories. And when we accessed my Linux operating system and we went to my /home directory, we could see the user home directory of Ubuntu. And we also said that some users do not have their user home directory inside of /home. For example, the root user has its user home directory inside of /root. In Linux, you also have to know that some users are provided with a share interface which they use to interact with the Linux operating system. And this share interface can either be bash, zshare, or just share. You also have to know that users can belong to one or more groups. For example, you may have a group for developers. You may have another group for DevOps engineers. Let's say you have a DevOps engineer called John. You can add John inside of this group called DevOps, and you can also add John inside of this group called developers. So John will have the permissions that DevOps engineers have, and he will also have the permissions that developers have. In Linux, there's a specific place you can go to have an idea of all the users that you have on your Linux operating system, and that is etc/password. Another place you can go to see the password of your user is inside of the /etc/shadow, right? So if you can cut this etc/password, you would have information about your users, and if you can cut etc/shadow, you'll be able to see their passwords. I also want you to know that in Linux there are different types of users. You have the root user, you have regular users, you have system accounts, and you have service accounts. So we're going to go through these users and understand the role they play on a Linux operating system. The first that we're going to look at are super users account or root account. The first thing I want you to know about this type of users in Linux is that they have full system access. The super user has unrestricted access to all files, directories, commands, and resources on your Linux operating system, meaning they can do anything on your Linux operating system. They can access all the files that are on your Linux operating system. They can access all the directories that are on your Linux operating system. They can run commands. They have access to all the resources that are on your Linux operating system. The second thing you have to know is that this account is usually referred to as root. So whenever someone is talking of the root account, I want you to know that they're talking of the super user account. Another characteristics of root account is that they have a user ID of 0, and I'm going to show you how to see this user ID when we're going to be creating users in Linux. Another thing you have to know is that they have the highest privilege in Linux. So they have the highest permissions in Linux. And because they have the highest permissions in Linux, they can do things like modify system files and configuration. So if they feel like the system needs to be changed, they can do it. They can install software, they can remove software, and they can manage softwares in general, something that other users users cannot do. They can add, remove, and modify user account and permissions. What this point is trying to say is that a super account can create other accounts and they can assign permissions to users, and they can also take permissions from those users and they can delete those users if they want to. That's how powerful this account is. They can also change ownership and permission of files or directories. So they can create a directory and they can assign that directory, for example, to John, and they can also take that directory from John and assign it to Peter. They have the powers, to do that. They can start, stop, and modify system processes. They have the powers to do that as well. Don't worry, we're going to talk about what system processes are. Another thing you have to know about my user account is that you can log in directly into a Linux system as a super user account, either using password or using a key. And I made a video on how to SSH where I showed you how to use a password and how to use a key. So if you have the password of root, you can use that password to log in into a Linux server. Another thing you have to know that's important is that your default share is the bin/bash share or the bin/share. Even though this is the most powerful account in Linux, there are some risks in using this type of account to do different things on your Linux operating system. The first one is mistake. If you make a mistake and you delete critical files or you do some misconfiguration on your system, it can take down your entire application or database or whatever service you're running on that system. The second thing is that is a target for attackers or hackers, right? It's a target for hackers. So if you don't protect this account and you store the credentials of this account somewhere that hackers can find it, trust me, they would find it and they will use it to get into your system. And because they are super users, they can literally do anything on that system, including deleting your application, deleting other users from the system, changing the password. They can do a lot of things on your system. So if you're thinking of using this account to do different things on your system, make sure that the password is stored somewhere that no one has access to. Or most importantly, don't even use this account to do things. Instead of using the root account to do specific things on your Linux system, this is what you can do instead. You can use the sudo for administrative tasks instead of logging in as root. What this point is trying to say is that you can assign administrative permission to a regular user and they can assume these permissions and use it whenever they want to do something specific, right? By doing this, it will keep your account safe, right? Another thing is that keeping the root account secure with a strong password or disabling direct login, especially for servers. You can create an extremely powerful password that it will be difficult for someone to guess or for someone to crack. Or you can just disable login into this account. So you cannot log in into this account, right? You have to log in as a regular user, then you have to use the command sudo and you switch to the root user and you do whatever thing you want to do. Or you may just use the sudo command to borrow some powers from the root account and use it to do whatever thing you want to do on that system. The second type of account or user you will find on a Linux system is the regular user or the regular account. Some people also refer to this as the standard account. Regular accounts are designed for everyday tasks and general system usage. For example, if you log in into the server every day to check logs, to deploy applications, to do some basic administrative tasks like run some scripts, you would use a regular account. And another thing you have to know is that their permissions are limited, right? When we're talking about a super account, we saw that they had unrestricted access to the entire system. Regular accounts are not like that. Their permissions are limited. And the reason why they limit their permissions for, security. So if someone hacks into the system using the credentials of a regular account, they are only limited to what that regular account can do. If the regular account can only create files but cannot delete files, they cannot delete anything on that Linux operating system, including even changing changing their own password. When a regular account is created, regular account is assigned a user ID, and their user IDs always starts from 1000, right? So you'll see 1001, you'll see 1002, you'll see 1003, you'll see 1004, and so on and so forth. Another thing is that they all have personal directories inside of the /home directories, and these directories are known as what user home directories, right? And this is where they have all their files, right? This is where they have all their configurations, and this is where they have all their data. So their data, their files, their configurations are stored inside of the user home directory. Now, at times you may create a regular user and they will not come with the user home directory, right? Don't worry, I'm going to show you how to fix that. Just as super users, regular users are also provided a share for running commands and scripts, and it's usually bash bin /bash or bin/share, right? So they usually provided this, but most of the time you're going to see a bin/bash, and I'm going to show you how to know the type of share that a specific user in Linux is using. As I said earlier, they have limited access to do certain things on the server. Like, for example, they cannot perform administrative tasks without elevated privileges, meaning that if they want to add users, for example, they don't have the permission to add a user unless they're given the sudo permission to be able to add a user. So the third type of account in Linux is what they call a system account. The first thing I want you to know about system account is that they are used for system operations or service management, not tied to human users. They also have a user ID. Their own user ID is usually below 1000. So you're going to see something like this, 999. That's how you're going to see their user ID. And I'm going to show you, how their user ID looks like. The main purpose of system accounts is to run background processes, run system daemons or services like, web servers and databases. That's kind of their main use, right? Another thing you have to know is that you cannot log in into a system account. They don't have, login access, right? And if you, look into their configuration, you're going to see that they have sbin/no login or the sbin/false to prevent any direct logins. One thing I love about this type of accounts is that they are created automatically. You have, for example, the daemon generic account for background processes. Then you have the nobody used for unprivileged and anonymous operations on your Linux operating system. So these are just examples of some system accounts that are inside of your Linux operating system, and I'm going to show you exactly how to find them. The fourth type of account we're going to talk about is the service account. Now, the service account is similar to the system account, right? And at times some people will just say the three accounts in Linux. They will just say you have regular accounts, you have super accounts, and you have service accounts, and they will not mention system accounts because system accounts at times they tend to behave like service accounts. So the first thing I want you to know about service account is that they're designed to run specific services or applications on your Linux operating system, like for example databases and servers. And an example of a service account would be www-data for Apache. You also have MySQL for MySQL server, and you also have SSHD for the SSH daemon. So these are examples of service accounts that you can find on your Linux operating system. They are also assigned a user ID. It's also below 1000. As I said earlier, you're going to see similarities between them, between service account and system accounts. Also, they don't have a login, so you cannot use their credentials to log in into a server because they don't have an interface for you to log in. And if you look at their configuration, you are also going to see the sbin/no login or the bin/false. Their permissions are only limited to the service that they're running. Apart from that, they cannot do anything. So they are often created automatically during the installation of softwares, and they can also be created by administrators, right? That's kind of something you have to remember. For the permissions they have, this type of account or this type of users, they are only limited to the files and the directories they need to run a specific service service or they need to function properly. They don't have full access, similar to system accounts who also do not have full access. Service account also do not have full access as well. So they're only limited to the files and directories that they will need to run a specific service properly. I know you're probably asking yourself, but Emmanuel, these accounts are the same, the system and service account, they're the same. But let's see some differences. Let's start with this, system account, right? Used for generic system level and background operations. For example, you have the daemon, bean, and nobody. Now, service account dedicated to running specific services or applications. That's your role, right? So a system account is a general purpose type of account used to run background processes. Service accounts, they are used to run specific services or applications that are on your system. Another thing is that, let's look at this. It says system account, broad scope, supporting overall system functionality or legacy processes, right? Service account, narrow scope, so it has fewer permissions, tied to a single service or application, ensuring isolation. That's kind of the difference between the two. Another thing is creation, often pre-created by the operating system during installation. As I said earlier, you can be installing your operating system and it would create a system account for you automatically. But service account usually created when installing a specific service or application or software, right? So that's kind of the difference between the two. So you notice that even though they have similar characteristics and they kind of sound like they used to do the same thing, but deep inside they have different functionalities and they are used for different purposes. So guys, that's what a user is in Linux, and that's the different types of users that we have in Linux. In our next video, we are going to see how create users, create groups, assign them permissions, put them in groups, take permissions from them, delete users, delete groups, and stuff like that. So thank you guys for watching this video. Please do not forget to like, share, and see you in my next video. Bye. Hello guys, what's up? Welcome back. Here's your guy Emmanuel Gijon, and in today's video we're going to see how to create users in Linux. So in my last video I explained what a user is in Linux, or who is a user in Linux, and I also gave you guys the 4 types of users that are in Linux. If you have not watched that video, please make sure you go watch that video before you watch this video. So in today's video we're going to learn how to create users, how to assign permissions to users, how to delete users. We're going to learn how to create groups, how to assign permissions to groups, and how to add users inside of groups, and also how to remove users from specific groups, right? So that's what we're going to be doing today. So before I start this video, please do take some time to subscribe to this YouTube channel. I've noticed that 80% of people that are watching my YouTube videos have not yet subscribed to my channel. So please, if you feel like you want to encourage me to keep making videos, please take some time to hit that subscribe button, and I'll be more than happy if you do it. So without taking much of your time, let's get started. So I'm back here in my machine, right? As you can see, I'm currently logged into my server as Ubuntu, and if I run the command, who am I? You see, it's going to say Ubuntu. So the first thing I want us to do is I want us to first of all know how to check how many users are on our server, or how many users are on our Linux operating system. So there are 2 ways you can check. The first way is that you can do a cd to the root directory, you do an ls, and you go inside of the home directory. So I'll do a cd home, hit enter, then you do an ls. Then inside of the home directory, you're going to see a folder here called Ubuntu, and this folder or directory is the user home directory of the user Ubuntu. So if you create another user, for example, John, Michael, Alice, Emmanuel, we're going to see their directories right here. Now, the issue with checking users on your system by going into the user home directory is that not all users have a user home directory. In my last video, I said there were 4 types of users. You had the root user, you had regular users, and you had system accounts and service accounts. And I also said system accounts and service accounts, they do not have a user home directory, even though they are users on the Linux operating system. So the best way to check your users is to use this command right here. So what I want to do, first thing first, let me just cd into Ubuntu. I'm going to clear my screen and I'm going to use the command cat/etc/password and I'm going to hit enter. Now, when you use this command cat/etc/password, is going to list all the users that are on your Linux operating system or all the users that are on your Linux server. As you can see, here we have the root user and we also have Ubuntu right here, and all of these right here are different users that are on our system. Remember, there are 4 types of users. You have root, you have regular users, you have system users, and you have service account. So some of these right here are service accounts. For example, this is a service account right here, and right here also we have a system account as well. So as you can see, there are a couple of users on our Linux operating system. Now another command we can use is I can do a cat etc/password, then I can pipe this and I will say word count -l and I will hit enter. As you can see, it says 35. So since each line in this file represents a user, it means there are approximately 35 users on our server right now. So basically what this command does is that it gives you an idea of how many lines are inside of this file right here called password. So if I go back inside of that file, you're going to see that we have our current user right here called Ubuntu. But the question now is, what is this X right here? What is this 1000? What is this other 1000? In short, what is all of this, right? And in this video, I'm going to explain that. But before I explain all of this, let's create a user. So I'm going to start by creating a user called a manual. So in Linux, there are 2 commands you can use to create a user. You can do an @user and you can also use a user @. So the first one we're going to use in this video will be the @user. So I'm going to say @user. I'm going to say @user Emmanuel Chijo and I'm going to hit enter. As you can see, we don't have the permission to add a user. The error message says other root may add a user or group to the system, right? Other root has the powers to add a user or a group to this system, right? So what we're going to do is we're going to use the sudo command. Sudo here stands for super user do. So what the sudo command does is that it allows us or it permits us to borrow some powers from the root user and use it to create or to run our command. So what we're doing right now, when we say sudo, we're basically borrowing some powers from root in order to run this command right here. So I'm going to do a sudo @user Gijon and I'm going to hit enter. It's going to ask me for the password of the user. So I'm going to do password. I'm going to put his password in there. I'm going to hit enter. It's going to ask me for his full name. So I'm going to put his full name in here. It's going to ask me for a room number. I'm just going to put a random number. It's going to ask me for a phone number, so I'm just going to put a random phone number. And it's going to ask me for a home phone number. No, I'm just going to hit continue. Yes, everything looks good. And as you can see, it says adding user Emmanuel Gijon to group users. So let's go and check to see if that user was added. So what I'm going to do is cat/etc/password. Then I'm going to hit enter. Now, if you look carefully right here, you're going to see that the user Emmanuel was added. Now, let's understand, what we're looking at right here. So what I'm going to do is I'm going to clear my screen and I'm going to use that cat command one more time. But what I'm going to do is I'm going to do a pipe grep Emmanuel Gijon. I'm going to hit enter. So what I'm doing with this command right here is that I'm asking the system to only print, the line that has the words Emmanuel Gijon in it, right? As you can see, this is that user right here. So let me explain what we are looking at right here. So the first thing you're looking at right here is the username of this user. And the username was given during the creation of this user. Then the second thing you're looking at right here is the password of this user. And this X is simply indicating that the password of this user is stored in another file. By the way, the password of this user is stored in a shadow file. And if we do a cat etc/shadow and we hit enter, it says we don't have permissions. That's fine. So I'm going to do a sudo. I'm going to hit enter. And if you, check right here, you're going to see that this is the password of that user called Emmanuel Gijon. But what I want you to understand is that this is not the actual password, right? This is the hash version of the password. Now, don't worry about what hashes are. Now, the fact that this is a hash version does not mean that you can expose this password, because if you do, hackers can find this hash version, they would crack it, and they would get the actual password of this user, and they may use it to log into your account, right? So the fact that it's in a hash version does not mean that you can just expose it. You still have to protect it. So what I want to do is I want to go back to that my command, this command right here. So what you're looking at right here is the password. Now what you're also looking at right here is the ID of the user. And because this is a regular user, the ID of this user will always start with 1000. As you can see, this is 1001. And now this is what they call the group ID. Let me explain something. When you create a user in Linux, a group for that user is also created. So when I created the user Emmanuel Gijon, a group was also created called Emmanuel Gijon, and this group belongs to the user Emmanuel Gijon. And right here is the ID of that group that was created when the user Emmanuel Gijon was created. And here you have some personal information about that user, right? And another thing you're going to see here will be the user home directory of this user, and you're also going to see the default shell that this user is using. In this case, this user is using a /bin/bash shell. Now another thing we can do here is that if I do an ls-l and I do a /home, you're going to notice that a user home directory was created for this user Emmanuel Gijon. So now we have two user home directories inside of the home directory. Let's add another user. So we're going to assume that this user Emmanuel Gijon is a DevOps engineer. So we want to add another DevOps engineer to our system, right? So what I'm going to do is, instead of using the @user command, I'm going to use the user command, right? So what I'm going to do is I'm going to do a sudo user and I'm going to call this user Alice. So I'm going to call this user Alison, or let's say Alice Johnson. That would be the user. And I'm going to hit enter. I want you to notice a couple of things. One, this command didn't ask us to put a password or to give a name or to put a room number. It didn't ask us none of that. It went straight and it created that user. Now let's check if we're going to see that user. So if I do a cat/etc/password and I hit enter, you're going to notice that there's a new user on our system called Alice, right? Let's see. So if I do, let me clear my screen, and I'm going to do a cat/etc and I'm going to grab Alice. I'm going to hit enter. Now, there are a couple of things I want you to notice. The first is that this is the username of that user, and it's saying that there's a password for that user. But the question is, did we give this user a password? No, we did not. So here is the user ID of that user, and here is the user ID of the group of that user, and here is the user home directory of that user. Now, this is something I want you to pay attention to. So let's go see if this home directory exists. So I'm going to do an ls-l and I'm going to do a /home and I'm going to hit enter. You're going to notice that even though we checked this user right here, it's telling us that there's a user home directory, but in reality, that user home directory was not created. Now, when you use the user command, it doesn't create a user home directory unless you pass an option for the user home directory to be created. Let me show you. So what we're going to do is we're going to delete this user from our system, right? So this is the next command that you're going to learn, the command to delete users. So what we're going to do right here is we're going to do a sudo user there, means user delete, and we're going to specify the user that we want to delete. In this case, we want to delete Alice, Jensen. Then we're going to hit enter. Now, if we do a cat/etc/password, you're going to notice that that user Alice is gone. But let's recreate that user. But this time we want to recreate that user with the user home directory. We want that user to have a user home directory just as Emmanuel has a user home directory. So what we're going to do is we're going to clear our screen right here, and I'm going to do a sudo user add, and this time I'm going to pass the option -n. It means create home directory. And I'm going to say I want to create a user called Alice Johnson, and I'm going to hit enter. So now if I do a cat /etc/password and I hit enter, you're going to notice that now there's a new user on our system again called Alice Johnson. Now let's see this Alice Johnson and let's understand what's going on here. So I'm going to do a cat /etc/password. I'm going to pipe. Don't worry about what pipe is. I'm going to teach you what pipe is, but for now, just know that I'm going to pipe this. I'm going to create. I'm going to say I want to see only the line that has, Alice in it, right? I'm going to hit enter and this pops up. So right here, the first thing we notice is that there is a username for Alice, which is correct, but it says there is a password. But when we created this user, we didn't give it a password. So why is the system telling us that there's a password? Now, the beauty of Linux is that we can go check if there's actually a password for Alice. So let's go check it out. So what I'm going to do here is I'm going to do a cat /etc/shadow and I'm going to hit enter. It says I don't have permissions. That's fine. So I'm going to do a sudo cat /etc/shadow and I'm going to hit enter. As you can see right here, this is that of Emmanuel, right? And we see that Emmanuel actually has a password. Now let's look at that of Alice. So when you look at that of Alice, you're going to see something that looks like an entry for a password, but that's not a password. Why? Because we didn't give it a password when we were creating that user. So let's do something. Let's give Alice a password. So in Linux, there is a command to assign a password to a user or change the password of a user, and that command is simply password. If you type password and you type the user you want to change the password or give or assign the password to, in this case Alice Johnson, right? Then I hit enter. It's gonna say I don't have permissions to modify password. That's fine. So I'm gonna do a sudo, then I'm gonna do password, then I'm gonna do Alice Johnson. I'm gonna hit enter. Then it's gonna ask me to give her a password. So I'm gonna put her password as Alice. I'm gonna confirm that password Alice, and it say password was successfully updated. So let's check if Alice now has a password. So I'm gonna do a sudo cat /etc/shadow file. I'm gonna hit enter. Now you see that there's a password for Alice stored in a hashed format, right? So that's kind of how you assign a password to a user or how you give a password to a user. So the next thing we're going to do is I want to do something, right? I want to do a cat /etc/password, and I want to pipe this again. I want to do a grape, then I want to do Alice, and I want to hit enter. Now, another thing that you're going to notice is that Alice right here has a different type of shell. So instead of a bash shell like Emmanuel, let me show you what I'm talking about. So I'm going to run this and I'm going to hit enter. So instead of a bash shell like what Emmanuel has, Alice has a /bin/shell, not /bin/bash shell. But we want Alice to have bash shell because Emmanuel here has bash shell, and when we look at Ubuntu also has a bash shell. So let's give Alice a bash shell. So what we want to do is we want to modify the shell that Alice is using. So I'm going to come back here. So what we want to do is we want to modify the shell that Alice is using. So there's a command for that. So it's sudo user mode, and user mode here stands for user modification. It's a command that makes it possible for you to modify users, or you can modify, you can add things, you can remove things from users, right? That's you use this command right here. So what we're going to do, we're going to use a user mode, and we're going to say want to modify Alice Johnson, right? And we're going to say --shell, and we're going to specify the new shell that we want Alice to have. So we want Alice to have this shell right here. Then I'm going to hit enter. Now if I run this command one more time, you're going to notice that Alice now has a /bin/bash shell. That's exactly what we want, right? Now let's say, for example, we don't like the username of Alice. We want to modify the username of Alice Johnson. So there's also a command to modify the username of a user in Linux, and that command is sudo user mode, because we want to modify the username of this user dash error. Error means change login name, and we're going to specify the new name. I want it to be Alice underscore Johnson, and we're going to specify the old name, which is Alice Johnson. I'm going to hit enter. Now, if I grab this user one more time, you're going to see that the username of this user was changed. Now, we also want to modify the username of Emmanuel. So what I'm going to do is I'm going to use the same command, and I'm going to, specify the new name, new username. I'm going to do Gijon, and the old one will be Emmanuel Gijon. I'm going to hit enter. Now, if I do a cat/etc/password and I hit enter, you'll notice that the username of Emmanuel has changed, and you also notice that the username of Alice has changed. Now, while we're here, let's talk about something. Come, let me show you something. Now, when you look at this user right here, so this is the first user that was on our system, the first regular user that was on our system, and that was Ubuntu right here. Now, when you look at the user ID of Ubuntu, you're going to notice that the user ID of Ubuntu is 1000. So because Ubuntu was the first regular user on our system, Ubuntu was assigned the user ID of 1000. The second user we created was Emmanuel, and you'll notice that the user ID of Emmanuel right now is 1001. Then the third user we created right here was Alice, and you'll notice that the user ID of Alice is 1002. So if we create another user, our system is going to assign 1003, 1004, 1005, 1006. So that's how user IDs are assigned to users in Linux. So now on our Linux operating system, we have two DevOps engineers, Emmanuel and Alice. So what we want to do is we want to ask Emmanuel to add some developers on our system. So let's go. So the first thing we're going to do is we're going to switch and become Emmanuel. So right now we are Ubuntu, but we want to become Emmanuel. So what I'm going to do is I'm going to use a command su. Su means switch user. The S stands for switch and the U stands for user. So switch user, I'm going to do dash, and I'm going to specify the username, that's Emmanuel. Then I'm going to specify the password of Emmanuel. I'm going to hit enter. Now you can see I'm on this server as Emmanuel, and if I run the command, who am I? I'm Emmanuel Gijon. Now Emmanuel wants to add some developers to the system, right? So Emmanuel wants to add some developers, so I'll do a sudo, and I will do add user, and I will call that user John underscore dev, right? To indicate that John is a developer, and I will hit enter. It's going to ask me for Emmanuel's password. So I'm going to put Emmanuel's password here. I'm going to hit enter. Now, look at this error. Pay very, very close attention to this error. What you're seeing here, what is the system saying? The system says that Emmanuel Gijon is not in the sudoers file. So what is this sudo file they're talking about, right? Now, remember when I was Ubuntu and I tried to add a user and it asked me to use sudo so that it would make it possible for me to add a user? It's simply because Ubuntu is part of a group called sudo. The file that controls who can get into that group and who cannot get into that group is a file called sudoers. This file we're talking about. So the sudoers file we're talking about is simply a configuration file that is on our Linux operating system that dictates or control who can use the sudo privileges. Like for example, Ubuntu is inside of that group. Let me show you. So if I switch back to Ubuntu, if I log out, now I'm back as Ubuntu, and I simply run the command groups, right? You see, it's not group, it's groups with an S. So I'm going to put an S, I'm going to hit enter. Now you're going to notice that it's going to list all the groups that Ubuntu is a member of. Now let me show you something. Now, when you look at this carefully, it says Ubuntu is a member of a group called Ubuntu. Remember when I said when you create a user in Linux, a group is also created? That's what happened with Ubuntu. So Ubuntu is a member of the group Ubuntu, but most importantly, Ubuntu is a member of a group called sudo. Now, Emmanuel is not a member of this group. Let's go back. Let's switch back to Emmanuel. So I'm going to switch back to Emmanuel. I'm going to put Emmanuel's password and I'm going to run the command groups. I'm going to hit enter. These are the groups that Emmanuel is part of. Emmanuel is part of a group called Emmanuel Gijon and is part of a group called users. And now if you check, he's not part of that group called sudo. And that's why Emmanuel cannot use the sudo command. So let's go and add Emmanuel inside of that file so that Emmanuel will be able to add users. Come, let me show you how you do it. So the first thing, you're gonna need someone with the permission to edit that file. And guess who? Ubuntu. So we're gonna switch back to Ubuntu right here. So I'm back as Ubuntu. I'm gonna clear my screen. Then the first command I'm gonna run is sudo vi. That's the other way to edit this file. Sudo right here. And I'm gonna hit enter. Boom. I'm inside of that file. So this is the file that controls who has the powers on your system to run a command using sudo. Come, let me show you. So if I scroll down, this is where the whole magic happens. These are the people that have the sudo permission. As you can see, root has the sudo permission. Let me explain what we're looking at right here. So we're looking at root right here. We're looking at root, and it says here or, and we have again this or, and we have again this or. What does that mean? Let me explain. So basically what they are saying here is that root as a user has the powers to execute on this host system or on all hosts. So root has the powers to execute a command on all hosts, and root has the powers to execute that command as a user or as a group, and at the same time root has the powers to execute all commands, right? So if I add a manual here, a manual will also have the same powers that root has. And right here, this is what they call a group. This is how groups are represented in Linux. So this is a group called admin, and it says members of the admin group may gain root privileges. So if you add someone to this admin group, that person will gain root privileges, right? And this is another group right here known as sudo, and it says all members of group sudo to execute any command. So if you add a user to this group called sudo, that user will have the powers to execute any command they want on your Linux operating system. Let me do something. I don't want to add a manual to any group. I want to make a manual powerful. I want to make a manual so powerful that he can destroy the entire system. I'm not going to add him to a group. I'm going to give a manual root privileges. I'm going to make a manual become a super user on this server. Come, let me show you. So what I'm going to do is I'm going to come right here and I'm going to add a manual underscore Gijon, and I'm going to say I want a manual to do everything that root can do. I want a manual to execute commands on this host. I want a manual to execute it as a user, as a group, and I want a manual to execute any command of his choice on this server. This is dangerous. This is extremely dangerous. This is not something that you would do. If you do it in a real war scenario, you would get fired by your manager. So this is not something that you do, right? So what I'm going to do is I'm going to do a Control O. I'm going to hit enter. Then I'm going to do a Control S. So now Emmanuel has all the powers. Emmanuel has the same powers that root has. Emmanuel can add users. When we tried to add a user the first time, we noticed that it didn't go through because they said Emmanuel was not part of the sudoers file, but now he's part of that file. So he can start adding users. So let me show you. So I'm going to switch back to Emmanuel. So I'm going to do a sudo dash Emmanuel Gijon. I'm going to put his password, and as Emmanuel, I'm going to add a user called John. So I'm going to do, sudo add user called John underscore dev, right? So it's going to help me know that this is a developer. So I'm going to hit enter, and it's going to ask me for Emmanuel's password. So I'm going to put his password in here. I'm going to hit enter. Now Emmanuel can create a user. I'm going to put his password as, I'm just going to call this John, right? I'm going to hit enter. I'm going to say John. I'm going to say John. I'm going to hit enter, and I'm just going to say his name is John Developer. Cool. I'm going to hit enter, 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 enter. Yes, enter. Boom. Now Emmanuel was able to create a user on this system. Why? Because he has the sudo permissions to do that. He has the powers to do that. Now let's see if this user exists. So I'm going to do a cat/etc/password, and I'm going to hit enter. Now you see there is a user on our system known as John Developer or John Dev or Dave. I don't know how you want to call it, right? But Emmanuel was able to add it, that user. But now here's the thing. We've given Emmanuel so much power. What if we want to give Alice the same power? Alice is part of the DevOps group. So Alice should also have the same powers that Emmanuel has. But here's the thing. You cannot keep giving powers to people directly. It doesn't make sense. That's not how you do it. In Linux, you create groups. So you create a group and you assign some permissions to that group and you add users inside of that group. Now, let me show you. So the first thing I'm going to do is I'm going to take Emmanuel off that file because I don't want him acting like root. Because if he's acting like root and someone hacks my server through Emmanuel, that person has root privileges. That person can literally blow off the entire system, and we don't want that. So what I'm going to do is I'm going to switch back and become Ubuntu, right? And I'm going to take Emmanuel off that file. So I'm going to do a sudo vi. I'm going to do sudo. I'm going to hit enter, and I'm going to take all of Emmanuel's powers, go down here, and I'm going to come right here, and I'm going to remove Emmanuel. I don't want him to have, this type of powers. So I'm going to remove him. Then I'm going to do a control O. I'm going to hit enter, and I'm going to do a control X. Just like that, Emmanuel has lost all his powers. What we want to do is, rather than giving all the powers to Emmanuel, we want to create a group, then give the sudo powers to that group, then add Emmanuel and Alice inside of that group. Let me show you how to do it. So the first thing we're going to do is, let's first of all see all the groups that we have on our system. And that command is cat/etc/group, and you hit enter. So this command is going to list all the groups that are on your system. As you can see, we have a lot of groups. Why do we have so many groups? Simple, because each time you create a user in Linux, a group is created for that user. That's why there's so many groups, on our system, right? You're going to notice that there's a group for Ubuntu, there's a group for Emmanuel, there's a group for Alice, and there's a group for John. Groups for everybody. So what we want to do is we want to create a new group. I want to call that group DevOps. So what I'm going to do, I'm going to clear my screen, and I'm going to do a sudo group add, and I'm going to call that group DevOps, like that. And I'm going to hit enter. So just like that, a new group was created called DevOps. Now I'm going to do a couple of things. So I'm going to see if that group exists, right? And right here, you will see that there's a new group called DevOps. Now the beauty is that you can also see who are the members of this group by using another command. I'm going to clear my screen, and I'm going to do a sudo getting group, and I'm going to specify the name of the group, in this case DevOps. I'm going to hit enter. So that's the DevOps group. And now there's nobody inside of this DevOps group, and it's just an empty group. It doesn't have permissions. So what we want to do, we want to give it sudo permissions. Then we want to add users to that group. How do you give sudo permissions? You have to edit the sudo as file. Come, let me show you. So what you do a sudo, then you do a vi sudo, and you hit enter. Now you edit the sudo file. So what I'm going to do, I'm going to come down here, and right here, I'm going to add another group. So I'm going to add that group DevOps. So I'm going to do DevOps, and I want it to have the same permissions as sudo. So I'm going to copy this, and I'm going to paste it right here. And what I'm going to do now is I'm going to save it, right? So I'm going to do a control O, hit enter, control X, and boom. Now that group has the sudo permission. So anyone that's added into that group will have the sudo permissions. Now let's add our two DevOps engineers, Alice and Emmanuel. Let's start by adding Emmanuel. So how do you add a user to a group? How do you do it? You use the user mode, right? We're modifying that user. We're adding that user to a group. So what you're going to do, you're going to do a sudo user mode -g, right? Then you're going to specify the name of the group, in this case, DevOps. And you're going to specify the username of the user you want to add to the group, in this case, Emmanuel. Then you're going to hit enter. Now, Emmanuel is part of that group. How do I know? There are two ways I can know, right? The first way is that I can run the command getting group DevOps, right? And right here, see the group DevOps, it has one member, and that member is Emmanuel, right? And I can also do a couple of things. I can also just do, a cat etc/groups, is group, not groups, right? Right here, boom. See, we have one user, and that user is Emmanuel. We also have to add Alice, because Alice is a DevOps engineer. So Alice should belong to this group. So you do what? You do a sudo user mode -g, then you specify the group DevOps, and you specify the user Alice, and you hit enter. Now Alice is part of that group as well. So if I cut this group, you'll see there's a user here called Alice. And if I use this other command right here, you see, now there are two people in this group. There is Emmanuel and there's Alice inside of this group. Both Emmanuel and Alice has sudo permissions. Now, we've seen Emmanuel perform things on our Linux operating system with a sudo permission. Let's see if Alice can do it. Let's switch to Alice. So I'm going to clear my screen and I'm going to do a su-i and I'm going to say I want to switch to Alice. I'm going to hit enter. What's the password of Alice? It's Alice. Then I'm going to do Alice. I'm going to hit enter. Now I'm like Alice. So if I do a who am I and I hit enter, boom, I'm Alice Johnson, right? And that's pretty cool. Now, another thing, I can see all the groups that Alice belongs to. So I can just do is groups. So I can do groups. And it says Alice belongs to a group called DevOps. And DevOps has the sudo permission. So let's see if Alice has the sudo permission. So the first thing, we're going to try to add a user. We're going to add another developer. We're going to call that developer Michael. So I'm going to do, this time, I'm not going to do an add user. I'm going to do a user add. That's faster. So I'm just going to do a user add -m. So it creates a home directory. And I'm going to say, I want a user called Michael_dev. And I'm going to hit enter. It says Alice does not have the permission to add a user. Why? We didn't use sudo. Let's try to use sudo. And I'm going to add sudo. I'm going to hit enter. It's going to ask me for Alice's password. So I'm going to do Alice. I'm going to hit enter. Now, that user was added. Let me show you. If we do a cat etc/password, we hit enter. You notice that there's a new user called Michael. So now Alice has the powers to add users, and we didn't give those powers to Alice. All we did was to add Alice into a group, and that group had the powers. So because Alice joined that group, she kind of inherited the powers of that group, and now she can use it to do crazy things. She can even create her own group, right? Let's see. Let's create another group. Let's create a group for developers, right? So what I'm going to do is I'm going to clear my screen and I'm going to create a group for developers. How do we create groups? We do a sudo and we do a group add and we call that group developers and we hit enter. A new group was created called developers. How do I know? If I say cat etc/group and I hit enter, you see? There's a new group right here. There's a new group right here called developers and it was created by Alice. Let's do a couple of things. Let's give this group some permissions, right? Can Alice edit the sudoers file? Yeah, she can't. Let me show you. So I'm going to clear my screen and I'm going to do a sudo vi sudo. I'm going to hit enter and boom, you see, she can edit the sudoer file. She has the powers to do that. And I'm going to come down here and I'm going to add that new group called developers. But now here's the thing. I don't want developers to have the same permissions that DevOps engineers have. They're developers. The only thing they should do is to restart, a web server. They should restart Nginx. They should restart, Apache. That's the only thing they should do. They are not developers, so they should not have full access to my entire server. Because since they are not system admins and they are not DevOps engineers, if they have full access, they can mess up that server. So we only want to give them the access they need, the ability to restart a web server. Apart from that, they should not do anything else. They should not even install something on our server without our permission. Come on, let's give them that permission. So what I'm going to do, I already have it written somewhere. I'm just going to copy it and I'm going to put it right here. We've added another group called developers, but we've not given them full permission, right? Look at this. Instead of giving them full permission, we only want them to execute these two commands. We only want them to, have the ability to restart Nginx or to restart Apache too. That's the only thing they should do. Why? Because they're developers, right? We can give them permissions. We can give them the ability to create users. We don't want that, right? So what we're going to do next is we're going to save this file, Control O, I'm going to hit enter, I'm going to do a Control X, and let's start adding users inside of that group. How many developers do we have? Let me check. So if I do a cat etc/password, you're going to notice that right now we have 2 developers. So let's add them to that group. So we're going to do a user, we're going to do a sudo user mode, and we're going to do a -g, and we're going to specify the group that's, developers, and we're going to specify the user, in this case, John. We're going to add John. So if I do a sudo user mode -g, let me explain something. If you add a user to a group and during the process of adding that user to that group and it kind of deletes all the groups that that user is part of, there's a command you can use. You can actually append that command. So you can come here and you can add, a -A to append, something like that. I don't really know. If you just add a -A, it's going to prevent that when you add them to a group, other groups are deleted, right? Hope that makes sense. Let me know in the comment section if that makes sense. So what I'm going to do is I'm going to specify the group developers, and I'm going to add our guy Michael. So now we have our 2 developers inside of the group developers. And the other thing these guys can do is restart web servers. Now let's see if they are in there. So I'm going to do a sudo get in, and I'm going to specify group, and I'm going to specify developers. I'm going to hit enter. Boom. As you can see, there are 2 users inside of that group, developers, and the only thing they can do as developers is to restart web servers. Now let's switch to one of those developers, right? So I'm going to switch, and I'm going to become John. So I'm going to do a su dash John. Gonna ask me for John's password. This is John, and now I'm John, and John is a developer. Let's see, can John add a user? So let me do a sudo user add, and John wants to add Paul, another developer, right? Maybe he reached out to DevOps engineer and system admins, and they were busy, and he said, oh, I'm gonna add it myself, and boom, password, which is password, hit enter. John doesn't have permissions to add it. Even though John is part of a group that's inside of the sudo file and has the sudo permissions, John doesn't have the permission to add users. John is limited because we actually limit the permission of John ourselves, right? So it says user John _ dev is not allowed to execute this command Paul, right, as root on this server, on this host, right? John is not allowed. Now John gets frustrated and he wants to delete everything. He goes crazy. He wants to delete everything. So John goes into the root directory. He lists all the directories, and he says, you know what? I want to delete every single thing that makes this server work. I want to delete, guess what? The etc directory, because it contains all the configuration of the system. So if it's deleted, the system won't work. So John decides and says, I'm going to use a sudo remove -r, and I'm going to delete etc directory. And he puts in the etc directory, hits enter, put in his password, he hits enter, boom. You see, he cannot delete that directory. He's not allowed to delete that directory. We restricted the permissions of John. He's not permitted to delete that directory. He gets frustrated and he says, you know what? I'm going to delete the boot directory, right? So let's try it. Let's try to delete boot. So I'm going to delete boot. I'm going to hit enter, and I'm going to put my user right here, my password. I'm going to hit enter. It says, sorry, you cannot do that. He doesn't have the permissions to do that. He's limited. Now, while he's doing this, someone finds out. Emmanuel finds out, Alice finds out, system admins finds out, the security team finds out, and they need to kick him out of the group. They need to take him out of the group. Let me show you how to take a user out of the group. But before we can take it out of the group, we have to become someone that can take a user out of the group. So either we become Ubuntu, we become Alice, or we become Emmanuel. I'm going to become Ubuntu, so I'm going to log out. As you can see, now I'm back as Ubuntu. Sorry guys, something happened to my camera, so I'm just going to continue off camera, right? So I'm going to shift this right here, and I'm going to continue off camera. So let's take out John. We have noticed that John is trying to take down our server. So let's take him. Let's remove him from that group. So let's first of all see all the groups that it's on our system. So let's do a cat /etc/ group, and let's hit enter. As you can see, there's a group called developers, and John is inside of this group, and John is trying to take down our entire system. So let's remove John. So I'm going to do a sudo, and I'm going to do a g passwords -d delete. Then I'm going to specify the user that I want to remove. In this case, it will be John, and I'm going to specify the group I want to remove John from, and that will be developers. And I'm going to hit enter, and it says removing user John from group developers. So John is no more part of that group called developers. So John has lost all his powers. Now let's delete John because he's trying to do some bad things on our server. So we're just going to do a user there. But before I delete, let me show you something. I'm going to do an ls-r, right? And I'm going to do a /home, and if I delete John, if I use the command sudo user there, and and I specify the user John, it's going to delete John, but it's not going to remove the user home directory of John. Let me show you. So I'm going to hit enter, right? Now, if I do a cat /etc/password, you're going to notice that John is gone. So if I do an ls-r, and I do a /home, right? You're going to notice that the user home directory of John is still there. It wasn't deleted when we removed John. Why? The reason Linux is doing this is because the user home directory of John is the personal workspace of John, and it contains all the files and configuration and data that belongs to John. So if you delete it and you delete the entire user home directory of John, you can delete some extremely important things that John was working on. Even though John is a hacker and he was trying to take down our server, but there are some files, there's some information that John is working on that we may need in the future. So that's why the system keeps the user home directory of a user when you delete that user. Now if you want to delete the user and the user home directory, now there's another command that you can use. So let's do something. Let's delete this user called Michael, because Michael is also a developer and we don't want developers on our system. So what we're going to do is we're going to do a sudo user there, and we're going to do a -r, and we're going to specify that user Michael. So I'm going to hit enter. Even though it gives you this error right here, that user was deleted. So if I do a cat/etc/password, you're going to notice that Michael is gone. If I clear my screen and I do an ls-r and I say /home and I hit enter, you're going to notice that it also deleted the user home directory of Michael, right? So that's kind of how you remove users from group and you delete users completely. Now what if we want to delete groups, right? So to delete groups, I will just do a sudo group there, and I want to delete that group called developers. I'm going to hit enter. Now if I do a cat/etc/group, you notice that that group developer is gone. I also want to delete the group DevOps, right? I don't want to keep DevOps, this none. So I will simply do a sudo group there DevOps. Now when I delete the group DevOps, I want you to know that everyone that's in that group with lose or loss, which one is correct? Let me know in the comment section which one is correct. So they will basically lose all their sudo privileges, and I'm going to hit enter, and now the group is gone, and Emmanuel and Alice, they don't more have sudo privileges on this machine. It's gone as well. The only person with sudo privileges right now is Ubuntu. So guys, that's kind of how you create users in Linux, assign permissions to them, put them in groups, create groups, assign permissions to groups. So that's kind of how you do some fun things in Linux. Thank you for watching this video. Please share this video with someone that's interested in learning Linux, and please do not forget to like, share, and subscribe. Please subscribe. See you in my next video. Bye. Hello guys, what's up? Welcome back. My name is Emmanuel Jijon. In this video, I'll talk about what file permissions are and how to change or read file permissions in Linux. This is an extremely important video. Why? Because knowing how to manage file permissions in Linux can help you restrict access to specific files that can cause damages on your system in case it falls in the hands of the wrong person. For example, with file permissions, you can stop people from deleting specific files on your server, and you can also prevent people from executing specific files as programs on your server. So without taking much of your time, let's get started. The first thing I want you to know is that whenever you create a file in Linux, so we're gonna assume that this is a file. So whenever you create a file in Linux, this file comes with permissions. So the first permission is the ability to read this file. So who can read this file? Who can see the content of this file? Another permission that's attached to this file is the write permission. That is, who has the permissions to edit this file and add content to this file. And the final permission that comes with this file is the execute permission. That is, who has the powers to execute this file on our system as if this file was a program. So whenever you create a file in Linux, you have the read permission, you have the write permission, and you have the execute permission. Read means who can read the content of this file. Write means who can edit this file and add content to it, and execute means who can run this file on our server as a program. You also have to know the different types or category of people who can access this file, right? So the first category of people who can access this file is the owner. So the owner can be the person who created the file or someone assigned the permission to own the file. For example, I can create a file and I'll be the owner of that file. A system administrator or DevOps engineer, whosoever, they can assign that file to John, right? And John will become the new owner of that file. So the owner here would have, the permission to read this file, to write on this file, or to execute this file as a program. The second category of people who have access to this file are groups. So a group is simply a collection of people that share the same permission, right? So groups can also have access to these files, and a group will have the ability to read, the ability to write, and the ability to execute this file as well. And the final group of people are others, right? That's any other user on your Linux operating system, right? Let me give you a summary of what I just talked about. In Linux, when you create a file, that file comes with permissions. The 3 permissions that's attached to that file. You have the read permission, you have the write permission, you have the execute permission. And there are 3 categories of people that can access that file. You have the owner, the person who created the file, or someone that was assigned to be the owner of that file. Then you have groups. That's people who share the same permissions, can also have access to that file. Then you also have others. That's any other user on your system, right? So now let's go into our server and let's run a command to see if we can find, the permissions that are attached to our files. So back here, I will run the command ls-l. We already know that when you run the command ls-l, it's going to list all the content that's inside of a specific directory. But what I want you to pay close attention to is this thing right here, right? What is this? And what is this right here? What is Ubuntu? What does that mean? Don't worry, I'm going to talk about this. So let's start with this portion right here. So this part contains the file permission. Let's understand what we're looking at right here, right? If you're new to Linux, this will sound kind of complicated and tricky, but let me break it down for you. Right here, we have a directory called app, right? And there are permissions attached to that directory. You have permissions that look like this: drw, xrw, xr-x. What does that mean? Now you can break these permissions into 4 categories. The first category here is this D right here. Then you have the rwx, right? Then you have the rwx, and you have the r-x. Let's understand what this means. This D here means directory. That's the meaning of D. So whenever you see a D, know that it's a directory. Up here is a directory, as you can see, has a D. Infrastructure is also a directory, as you can see, it also has a D. So this D stands for directory. Now, this R right here stands for read, and W stands for write, and this X stands for execute. Remember I said there are 3 permissions that are attached to a file in Linux: the read permission, the write permission, and the execute permission. So let me explain something to you. So as you can see, we already know that this right here is a directory. This first category, as you can see, there's 1, there's 2, and there's 3 right here. This first one is the owner. So this represents the permission that the owner of this directory has. As you can see, the owner of this directory has the permission to read, has the permission to write, and has the permission to execute, this directory right here. Now, because it's a directory, it doesn't mean executing it means running it as a program. It simply means the owner has the permissions to go inside of that directory. So if the owner does a cd into app, then he will go inside of that directory. That's what execute means when we're dealing with directories. Now, this second category right here, is the group. The group also has the permission to write, the permission to read, and the permission to execute as well. It means if you add anyone inside of this group, they will have the permission to write, read, and execute on this directory. And this third one right here simply represents the permissions of others, right? As any other user on our system. As you can see, they only have the permission to read and execute. They can't do anything else. So they only have the permission to see what's inside of the directory and to go inside of the directory, but they cannot delete the directory. They can change the name of the directory. No, they can create something inside of that directory. They only read and execute, right? Now, this little sign right here, that's a slash, it simply means no permission. So if you see that, know that it means no permission, right? So they don't have any other permission apart from these two permissions, right? So this is kind of what this here means. Now let's look at this one right here, the one of a file, this my_file.text. So we can also break this down into 3 categories like this right here. You have the first category, you have the second category, and you have the third category. Now when it has to do with a file, this here is indicating that this is a file. That's the first thing I want you to know. So whenever you see this dash here, know that it's a file. For example, this is a file right here. As you can see, there's that dash. This is another file right here. As you can see, there is that dash. So when you see it, know that that's a file. Now, in the first category, this is the permission of the owner, right? That's the person who created the file or the person that was assigned to be the owner of that file. So this second one right here are the permissions of the group. This third one right here are the permissions of others, right? That's any other user on our Linux operating system, right? Now let's look at the owner. So the owner here only has R will stand for read, then W will stand for write, X will stand for execute, and dash is equals to no permission. Now when we look at the owner, we're going to notice that the owner has the permission to read, right? And the owner also has the permission to write. So these are the 2 permissions that are assigned to this owner, and apart from that, they don't have any other permission. Like for example, they don't have the permission to execute this file as a program. Now the group also has the permission to read, and they also have the permission to write, but they don't have the permission to execute this file as a program. Others with an S represents any other user that's on our Linux operating system, and the only permission they have is the permission to read. In Linux, you can also see the owner and the group directly from this command right here. So as you can see right here, we have Ubuntu and we also have Ubuntu, right? So right here is the owner's name, right? So this part or this category represents the owner's name. So the owner of this file is Ubuntu, right? And Ubuntu has the permissions to read and write, but they cannot execute, right? For the directory, the owner also is Ubuntu, and Ubuntu has the permission to read, write, and execute on that directory. So this first category right here represents the owner's name, and in our next video we're going to see how to change the owner of a file and how to change permissions of a file. Now this right here represents the group name, right? As you can see, the group name is still Ubuntu. Why? Remember in my previous video I said when you create a user, a group is created for that user. So when the user Ubuntu was created, a group called Ubuntu was created as well. So when Ubuntu created this directory called app, the directory was automatically assigned to the group Ubuntu. So if I add someone inside of that group Ubuntu, that person would also have the permissions to do whatever thing Ubuntu can do on this directory or on these files, right? So this represents the owner's name and this represents the group name. That's also something I wanted you to know. So when it comes to modifying file permissions and file ownership, the 2 commands you have to know. The first command is the change owner, like this. This stands for change owner, right? And what this command will help you do is that it will help you change the owner of a file. For example, right now, the owner of this file and directory is Ubuntu. I can change that owner to Emmanuel. I can change that owner to John. I can change that owner to Peter. And if I want to do it, I need the change owner command, right? The second command you have to learn is the change mode command, right? Change mode, right? And basically, this is the command you're going to need to change, permissions. For example, if I want to make in such a way that Ubuntu can execute this file as a program, I can do it. I can use this change mode command and I can assign permissions, to Ubuntu to execute that file as a program. And I can also use the change mode command and I can use it to remove permissions from Ubuntu. For example, I don't want Ubuntu to have the write permission on this file. So I don't want Ubuntu to be able to edit this file right here. So I can use the change mode command and I can take away the permission to read that file from Ubuntu. So in our next video, we're going to see how to change the users of a file, change the permissions of a file, and also we're going to see how to use numerical values to assign permissions. For example, if I do a change mode 777 file name, what does that mean? If I do a change mode 666 file name, what does that mean? So in our next video, we're going to see how to do that. So thank you guys for watching this video. Please do not forget to like, share, and subscribe, and see you in my next video. Bye. Hello guys, what's up? Yes, a guy Emmanuel Jijong, and in today's video, we're going to see how to change file permissions and ownership in Linux. This is a continuation of my previous video. Before I start, please make sure that you subscribe to this YouTube channel and also make sure that you turn on the notification bell so that next time I post a video, you'll be the first person to be notified. I'm going to do an ls-l and it's going to list all the files and directories that are under my current working directory, right? So as you can see, I do have two directories. I have an app directory and I have an infra directory, and I do have two files as well. I have an app.py and I have my_by.txt, right? On the left side, you're going to see the permissions that are attached to this directory right here, and you're also going to see the name of the owner of this directory and the group this directory belongs to. So the first thing we're going to do is we're going to learn how to change owners, right? For example, this directory right here is owned by Ubuntu, but we want to change it to Emmanuel. So we want Emmanuel to be the new owner of this directory. So if you want to change the owner, you will use the command sudo change owner like this, change own, and you will specify the new owner. In this case is going to be Emmanuel Jijong. Then you specify the directory and you will hit enter. Now if I do ls-l, you'll see that the new owner of this directory app is now Emmanuel Jijong. And you can also change the group as well. And let's change the group. So let's see the groups that are on our system. So I will do a cat/etc/groups and I'll hit enter. So I want this group DevOps to be the new group of this directory right here. So in order for you to do that, you're going to do a sudo change owner. You're going to use this sign and you're going to specify the new group DevOps space and you specify that directory app. Then you hit enter. If I do an ls-l, you're going to notice that the new group is now DevOps, right? Now let's change this file right here. Let's change the owner of the file. So I want the owner to be Alice. So I'll do a sudo change own. And I'll say Alice Johnson and I'll specify the file, which is app.no.py, and I'll hit enter. Now if I do an ls-l, you'll notice that the new owner of this file called app is now Alice Johnson. Now we also want this file to belong to the group Alice. I'll do a sudo change owner, then I'll put colon and I'll say I want it to be Alice Johnson and I'll specify the name of the file. In this case is app. And I'll hit enter. Now if I do an ls-l, you'll notice that the new owner of this file is Alice Johnson and the new group is Alice Johnson. Now what if you want to change the owner and the group at the same time? Like for example, this infrastructure, right? I want the new owner to be Emmanuel and I want it to belong to the group DevOps, for example. So you simply do a sudo change owner. Then you specify the name of the new owner. In this case, it's going to be Emmanuel_Gijon. Then since you're changing the owner and the group at the same time, you use a colon and you specify, the group DevOps, and you specify, the directory infra, and you hit enter. So it says change owner. Sorry, I made a mistake with the command right here. So I'm going to correct this and I'll hit enter. Now, if I do an ls-l, you're going to notice that the owner of the file has changed to Emmanuel Gijon and the group has changed to DevOps. So let me clear my screen. Let me do an ls-l. And now, what if we want to change, permissions, right? So as you can see right here, the owner Emmanuel Gijon has the permissions to read, write, and execute, while the group has the permission to read, write, and execute. And others, that's any other user on our system, has the permission to read and execute. Now, what if we want the group to only have the permission to read and execute? We don't want them to have the permission to write. We can do that. So we're going to use the command sudo change mode. Since we're changing file permissions, we use the change mode. Whenever we're changing file ownership, we use the changed ownership command. But if we're changing the file permission, we use the change mode. So I'm going to do a changed mode. I'm going to hit space. Then I want to change the permission of the group. So I'm going to do a G. G means group. And what I want to do is I want to remove the write permission. So I'm going to do a minus and I'm going to specify the name of the permission that I want to remove. In this case, write. I'm going to hit space and I'm going to specify, either the name of the file or the directory. In this case is a directory called app. So I'm going to say app and I will hit enter. Now, if I do an ls-l, you're going to notice that the group does not have the permission to write. So group now only has the permission to read and execute, and others have the permission to read and execute as well. Now, what if we don't want others to have the permission to execute? So we only want them to have the permission to read, right? So you simply do a sudo change mode and you want to change the permission of others, that's O. And what you're doing is you're removing it. So that's a minus, and the permission you're removing is the execute permission, and you're removing it on this directory called. I'm going to hit enter. Now, if I do an ls-l, you're going to notice that others already have the permission to read, but they don't have the permission to write and execute, right? Now, let's move to a file. Let's do the same thing for a file. Looking at this file right here, you're going to notice that the owner, Alice Johnson, only has the permission to read and write. Then, while the group has the permission to read and write, and any other user on our system has the permission to read. So we want Alice to have the execute permission on this file right here. So you simply do a sudo change mode and you specify U. U stands for user. In this case, it's Alice. And since we want to add permissions, we're going to use, the plus sign, right? Because we're adding the permission to the user Alice. So we're going to use the plus sign and we're going to give Alice the permissions to execute, right? And we want Alice to execute on this, file right here called app.py. Then we're going to hit enter. Now, if I do an ls-l, you're going to notice that Alice now has the permission to read, write, and execute, right? As you can see, the color of the file has changed. And each time you give, execute permission to a file, the color is going to change to this. Now, this is not a guarantee with all the distributions out there. Now, you can see that Alice has the permissions to execute. It means Alice can now run this file on our system as if the file was a program. Now, let's do something. So we want the group to also have the permissions to execute, right? So I'm going to do a sudo change mode. Now we're dealing with the group and we want to give the group the permissions to execute on this file called app. I'm going to hit enter. Now, if I do an ls-l, you're going to notice that group Alice Johnson also has the permissions to execute, right? And others do not have the permissions to execute. Let's say we don't want group to have any permission on this file. So we can do a sudo change mode group minus, and I can take away the ability to read, write, and execute on this file right here. And I'll hit enter. If I do an ls-l, you're going to notice that the group does not have any permission. Let's look at this file. What if we want Ubuntu to be able to execute this file as a program? Right, so we're simply going to do a sudo change mode. Then we're going to say user plus execute on this file. We're going to hit enter. So if I do an ls-l, you're going to notice that Ubuntu now has the permissions to execute, and this is the new color of that file. We don't want group or others to have any permissions whatsoever, so we can take that out. So I can do a sudo changed mode group, and I want to take out their ability to read and write on this file right here. When I hit enter, then I want to do the same thing for others, right? I'm going to hit enter. I want to take the permission for them to write. I'm going to hit enter. Now, if I clear my screen and I do an ls-l, you're going to notice that only Ubuntu has the permission to read, write, and execute on this file. No other user can do anything on this file apart from Ubuntu. What if you want to change permissions using numerical values, right? So I want you to remember this little diagram that I'm going to draw. So I'm going to draw a little table where we're going to have the permissions, we're going to have the symbol, and we're going to have the number. So the permission to read is R and the number is 4. It's a standard thing. The permission to write is W and the number is 2, and the permissions to execute is X and the number is 1. No permission is like this and the number is 0. So I want you to pay close attention to this, right? So now if I do an ls-l and I hit enter, you're going to notice that Emmanuel Gijon has the permission to read, write, and execute, right? So if you want to add this, it's going to be read is 4, write is 2, that will be plus 2, and execute is 1, that will be plus 1, that will be 7. So using numerical values, the read, write, and execute is 7. The group has the permissions to read and execute. So read is 4, there's a dash right here, meaning no permission is 0, and execute is 1. So this permission here is 5. Others, that's any other user on our system, has the permissions to read and nothing else. So it's 4 plus 0 plus 0, which is 4. So if you want to represent these permissions right here using numerical values, it's going to be 7, 5, 4. This is the permission right here. What if we want to change this permission using numerical values, right? What if we want the owner to only have the permission to read and execute? So we don't want them to have the permissions to write. So the read and execute it will be what? So the read would be 4 plus, we don't want them to have the permission to write, that will be 0, but we want them to have the permission to execute, that will be plus 1, that will be 5. For others, we only want them to have the permissions to read, but we don't want them to have the permission to execute, right? So the read would be 4 plus 0, 0, that will be 4. Then for any other user on our system, we don't want no permission at all, right? So that will be 0, 0, 0, which should be 0. So the new permission using numerical values would be 5, 4, 0, right? So let's try this out. So I'm going to do a sudo change mode, right? And I'm going to say 5, 4, 0 on this directory called app, and I'm going to hit enter. Right, so now if I do an ls-l, up here you notice that the owner Emmanuel has the permission to read, write, and execute, but down here you notice that the owner Emmanuel only has the permissions to read and execute, right? They don't have the right permission. You notice that group only has the permissions to read, but they don't have the permissions to execute. And you also notice that any other user on our system does not have permissions, right? So let me clear my screen. Let me do an ls-l and let's continue. For this one right here, Alice, we want Alice to have the permissions to read, write, and execute. We also want the group to have the permissions to read, write, and execute. And we have others to have the permission to read, write, and execute as well. So we can do that, right? So for the owner, I'm going to say owner. We want owner to have the permissions to read, write, and execute. So that will be 4 plus 2 plus 1 is equals to 7. For the group, we want the group to read, write, and execute. So that will be 4 plus 2 plus 1 would be 7. And for others, we want others to have the permission to read and execute. That will be 4 plus 0, right, plus execute is 1, that will be 5. So the new permission for this file would be 775. So let's try. Here, I'm going to do a sudo change mode, and I'm going to say 775 on file app.py. I'm going to hit enter. Now, if I do an ls-l, as you can see, Alice has the read, write, execute permission. The group Alice has the read, write, execute permission, something they didn't have up here. And any other user on our system has the read and execute, permission as well. Now, let's move to this next one. Let's say we only want the user, Emmanuel, to have the permission to read and write and execute. No other permission should be given to the group, and no other permission should be given to others, right? So let's do that. So in this case, the owner, we have the permission to read 4, the permissions to write 2, and the permissions to execute 1, that is 7. Group, we have no permission, so that's 0 plus 0 plus 0, that is 0. Others, no permission as well, so that's 0 plus 0 plus 0, that is 0. So this is 700, the new permission. Let's try it out. So here I will do a sudo change mode 700, and I will do an infra, and I will hit enter. If I do an ls-l, you notice that only the user Emmanuel has the permission to read, write, and execute. Group has no permission, and others have no permission as well. What if we want Ubuntu to have the permission to read, write, execute? What if we want everyone here to have the permission to read, write, and execute? We can do that. Owner will be 4 plus 2 plus 1, which is 7. Then group will be 4 plus 2 plus 1, which is 7. And others would be 4 plus 2 plus 1, which is 7. So the new permission will be 777, meaning that they all have the permission to read, write, and execute, right? So I'm going to do a sudo change mode 777 on my underscore file.text. I'm going to hit enter. Now, if I do an ls-l, you see Ubuntu has a permission to read, write, and execute. Group has the permission to read, write, and execute, and any other user on our system has the permission to read, write, and execute. That is how you change permissions in Linux using the change mode command. So guys, thank you guys for watching this video. Please do not forget to like, share, and subscribe, and see you in my next video.